Hello, so this is part 12 of the math journey. Yesterday I said 12, but it's actually part 11. And this is the real part 12. It's only 25% done, so I guess I can finish this all day. It's pretty short as well. Yeah, it's 1200 points only. The divisibility test start. But of course, the check again, recording, cool.
What we're going to do in this video are some real quick tests to see if these three random numbers are divisible by any of these numbers here. And I'm not going to focus a lot on the why of why they're divisible. We'll do that in other videos. But really just to give you a sense of how do you actually test to see if this is divisible by 2 or 5 or 9 or 10. So let's get started. So to test whether any of these are divisible by 2, you really just have to look at the ones place and see if the ones place is divisible by 2. And right over here, 8 is divisible by 2, so this thing is going to be divisible by 2. 0 is considered to be divisible by 2, so this is going to be divisible by 2. Another way to think about it is if you have an even number over here, and 0 is considered to be an even number, then you're going to be divisible by 2. So, and over here, you do not have a number that is divisible by 2. This is not an even number, this 5, so this is not divisible by 2, so I won't write any 2 there. So we've gone through the 2's. Now let's work through the 3's. So to figure out if you're divisible by 3, you really just have to add up all the digits and figure out if the sum is divisible by 3. Wow. So let's do that. So if I do 2 plus 7 plus 9, actually let me just write it out. Plus 9 plus 5 plus 8 plus 8. What's this going to be equal to? 2 plus 7 is 9. 9 plus 9 is 18. Plus 9 is 27. Plus 5 is 32. Plus 8 is 40. Plus 8 is 48. And 48 is divisible by 3, but in case you're not sure, so this is equal to 48. In case you're not sure whether it's divisible by 3, you can just add these digits up again. So 4 plus 8 is equal to 12, and 12 clearly is divisible by 3. And if you're not even sure there, you could add those two digits up. 1 plus 2 is equal to 3. And so this is divisible by 3. This right over here, let's add up the digits. And we can do this one in our head pretty easily. 5 plus 60 plus 2 divisible by. You're not sure. 8, 40 plus 8 is 40 is equal to 48. In case you're not sure whether it's divisible by 3, you can just add these digits up again. So 4 plus 8 is equal to 12, and 12 clearly is divisible by 3. And if you're not even sure there, you could add those two digits up. 1 plus 2 is equal to 3. And so this is
What is 48 divided by 3? 16,
divisible by 3. This right over here, let's add up the digits. And we can do this one in our head pretty easily. 5 plus 6 is 11. 11 plus 7 is 18. 18 plus 0 is 18. And if you want to add the 1 plus 8 on the 18, you get 9. So the digits add up to 9. Digits, let me do this in a, so these add up to 9. Well, they add to 18, which is clearly divisible by 3 and by 9, and these two things will add to 9. So the important thing to know is when you add up all the digits, the sum is divisible by 3. So this is divisible by 3 as well. Divisible by 3. And then finally, let's add up these digits. 1 plus 0 plus 7 is 8. Plus 6 is 14. Plus 5 is 19. Did I do the 8? Yep, 19. So that we summed up the digits. 19 is not divisible by 3. So this one, we're not going to write a 3 right over there. It's not divisible by 3. Let's try 4. And to think about 4, you just have to look at the last two digits. And to see, are the last two digits divisible? Are the last two digits divisible by 4? Immediately, you can look at this one right over here. See, it's an odd number. If it's not going to be divisible by 2, it's definitely not going to be divisible by 4. So this one's not divisible by any of these first four numbers, these first few numbers right over here. But let's think about this one. 88, is that divisible by 4? And you can do that in your head. That's 4 times 22. So this is divisible by 4. Now let's see. 4 goes into 60 15 times. And then to go from 60 to 70, you have to get another 10, which is not divisible by 4. So that's not divisible by 4. And you could even try to divide it out yourself. 4 goes into 70. See, 1 times. You subtract, you get a 30. 4 goes into 37
7
times. You multiply.
So
Then
about to
you
say 8.
subtract. You get a 2 right over here as your remainder. So it is not divisible by 4. Now let's move on to 5. And this is probably, you're probably already very familiar with
Yeah,
this.
5 or
If your
0.
final
It
digit
depends
is a
if
5 or a 0, you are divisible by 5. So this one is not divisible by 5. This one is divisible by 5. You have a 0 there. So this is divisible by 5. And this, you have a 5 as your ones digit. So once again, finally, this is divisible by something. It's divisible by 5. Now the number 6. The simple way to think about divisibility by 6 is that you have to be divisible by both 2 and 3 in order to be divisible by 6, because the prime factorization of 6 is 2 times 3. So here we're divisible by 2 and 3, so we're going to be divisible by, we do that in a new color, so we're going to be divisible by 6. Here we're divisible by 2 and 3, so we're going to be divisible by 6. And if you were just divisible by 2 or 3, just one of them, then you wouldn't be able to do this. You have to have both a 2 and a 3, divisibility by both of them. And here you're divisible by neither 2 nor 3, so you're not going to be divisible by 6. Now let's do the test for 9. The test for 9 is very similar to the test for 3. Sum up all the digits. If that sum is divisible by 9, then you're there. Well, we already summed up the digits here, 48. 48 actually is not divisible by 9. If you're not sure, you can add up the digits there. You get 12. 12 is definitely not divisible by 9. So this thing right over here is not divisible by 9. And this one over here, if you added up all the digits, we got 18, which is divisible. It is divisible by 9, and I'm running out of colors, so this one is divisible by 9. All the digits added up to 18. And this one over here, you don't even have to add them up, because we already know it's not divisible by 3. If it's not divisible by 3, it can't be divisible by 8. But if you did add up the digits, you get 19, which is not divisible by 9. So this also is not divisible by 9. And then finally, divisibility by 10. And this is the easiest one of all, because you just have to see if you have a 0 in the ones place. You clearly do not have a 0 in the ones place here. You do have a 0 in the ones place there, so you are divisible by 10 here. And then finally, you don't have a 0 in the ones place here, so you're not going to be divisible by 10. Another way you could think about it, you have to be divisible by both 2 and 5 to be divisible by 10. Here, you are divisible by 5, but not by 2. But obviously, the easiest one is to just see if you have a 0 in the ones place.
Determine whether 380 is divisible by 2, 3, 4, 5, 6, 9, or 10. They skipped 7 and 8, so we don't have to worry about those. So let's think about 2. So are we divisible by 2? Let me write the 2 here. Divisible by 2. Well, in order for something to be divisible by 2, it has to be an even number. And to be an even number, your ones digit, so let me rewrite 380. To be even, your ones digit has to be even. So this has to be even. And for this to be even, it has to be 0, 2, 4, 6, or 8. And this is 0. So 380 is even, which means it is divisible by 2. So it works with 2. So 2 works out. Let's think about the situation for 3. Now, a quick way to think about 3, so let me write just 3 question mark, is to add the digits of your number. And if the sum that you get is divisible by 3, then you are divisible by 3. So let's try to do that. So 380, let's add the digits. 3 plus 8 plus 0 is equal to 3 plus 8 is 11 plus 0 is, so it's just 11. And if you have trouble with figuring out whether this is divisible by 3, you could then just add these two numbers again. So you can actually add the 1 plus 1 again, and you would get a 2. Regardless of whether you look at the 11 or the 2, neither of these are divisible by 3. So not divisible by 3. And maybe in a future video I'll explain why this works. And maybe you want to think about why this works. So these aren't divisible by 3, so 380. So 380 is not divisible. 380 not divisible by 3. So 3 does not work. We are not divisible by 3. Now let's think about the situation. Let's think about the situation for 4. So if we're thinking about 4 divisibility. So let me write in
So I'm
orange.
just gonna grab coffee. Alright, I'm back.
So we are wondering about 4. Now, something you may or may not already realize is that 100 is divisible by 4. It goes evenly. So this is 380. So the 300 is divisible by 4. So we just have to figure out whether the leftover, whether the 80 is divisible by 4. Another way to think about it is, are the last two digits divisible by 4. And this comes from the fact that 100 is divisible by 4. So everything the hundreds place or above, it's going to be divisible by 4. You just have to worry about the last part. So in this situation, is 80 divisible by 4?
Yep.
Now, you could eyeball that. You could say, well, 8 is definitely divisible by 4. Or 80 divided by 8 divided by 4 is 2. 80 divided by 4 is 20. So this works. Yes. Yes. So since 80 is divisible by 4, 380 is also divisible by 4. So 4 works. 4 works. So let's do 5. Actually, scroll down a little bit. Let's try 5. So what's the pattern when something is divisible
0
by
and
5? Let's do the multiples of 5. 5, 10, 15, 20, 25. So if something's divisible by 5, I could keep going. So divisible by 5. That means it ends with either a 5 or a 0, right? Every multiple of 5 either has a 5 or a 0 in the ones place. So 5 or 0 in ones place. Ones place. Now, 380 has a 0 in the ones place. So it is divisible by 5. Now, let's think about the situation for 6. Let's think about what happens with 6. So we want to know, are we divisible by 6? So to be divisible by 6, you have to be divisible by the things that make up 6. Remember, 6 is equal to 2 times 3. So if you're divisible by 6, that means you're divisible by 2 and you are divisible by 3. If you're divisible by both 2 and 3, you will be divisible by 6. Now, 380 is divisible by 2. But we've already established that it is not divisible by 3. If it's not divisible by 3, it cannot be divisible by 6. So this gets knocked out. We are not divisible by 6. Now let's go to 9. Let's go to 9. So divisibility by 9. So you can make a similar argument here that if something is not divisible by 3, there's no way it's going to be divisible by 9, because 9 is equal to 3 times 3. So to be divisible by 9, you have to be divisible by 3 at least twice. At least 2 3's have to go into your number. And this isn't the case. So you could already knock 9 out. But if we didn't already know that we're not divisible by 3, the other way to do it is a very similar way to figure out divisibility by 3. So we can add the digits. So you add 3 plus 8 plus 0, and you get 11. And you say, is this divisible by 9? And you say, this is not divisible by 9, so 380 must not be divisible by 9. And for 3, you do the same thing, but you test whether the sum is divisible by 3. For 9, you test whether it's divisible by 9. So lastly, we have the number 10. We have the number 10, and this is in some level the easiest one. What do all the multiples of 10 look like? 10, 20, 30, 40. We could just keep going on and on. They all end with 0. Or if something ends with 0, it is divisible by 10. 380 does end with 0, or its ones place does have a 0 on it. So it is divisible by 10. So we're divisible by all of these numbers except for 3, 6, and 9. Does have a 0 on it. So it is divisible by 10. So we're divisible.
The y of the
You're just walking down the street and someone comes up to you and says, quick, quick, 4,792. Is this divisible by 3? This is an emergency. Tell me as quickly as possible. And luckily, you have a little tool in your toolkit where you know
11,
how to test for divisibility by 3.
no.
You say, well, I can just add up the digits. If the sum of that is a multiple of 3, then this whole thing is a multiple of 3. So you say 4 plus 7 plus 9 plus 2. That's 11 plus 9 is 20 plus 2 is 22. That's not divisible by 3. If you were unsure, you could even add the digits of that. 2 plus 2 is 4. Clearly not divisible by 3. So this thing right over here is not divisible by 3. And so luckily that emergency was saved. But then you walk down the street a little bit more and someone comes with you, quick, 386,802. Is that divisible by 3? Well, you employ the same tactics. You say, well, what's 3 plus 8 plus 6 plus 8 plus 0 plus 2? 3 plus 8 is 11, plus 6 is 17, plus 8 is 25, plus 2 is 27. Well, 27 is divisible by 3. And if you're unsure, you could add these digits right over here. 2 plus 7 is equal to 9. Clearly divisible by 3, so this is divisible by 3 as well. And so now you feel pretty good. You've helped two perfect strangers with their emergencies. You figured out if these numbers were divisible by 3 very quickly. But you have a nagging feeling because you're not quite sure why that worked. You've just kind of always known it. And so let's think about why it worked. And to think about it, I'll just pick a random number. But we could do this really for any number. But I won't go too proofy on it, just so that you can see it's pretty common sense here. And the number we'll use is 498. I could literally use any number in this situation. And to think about why this whole little tool or this little system works, we just have to rewrite 498. We can rewrite the 4, since it's in the hundreds place, we could write that as 4 times 100. Or 4 times 100, that's the same thing as 4 times 1 plus 99. That's all this 4 is. It's 400, which is the same thing as 4 times 100, which is the same thing as 4 times 1 plus 99. And the little trick here is that I want to write, instead of writing 100, I want to write it as the sum of 1 plus something that is divisible by 3. And 99 is divisible by 3. If I had more digits here, 999, 9,999, they're all divisible by 3. And this is why you can do the same reasoning for divisibility by 9, because they're all divisible by 9 as well. Anyway, that's what that 4 in the hundreds place represents. This 9 in the tens place, well, that represents 90, or 9 times 10, or 9 times 1 plus 9. And then finally, this 8, that's in the ones place, that's just 8 times 1, or we could just write plus 8.
Yo. Oh, 9 times 1.
Now, we can distribute this 4. This is 4 times 1 plus 4 times 99. So it's 4 plus 4 times 99. Actually, let me write it like this. I'm going to write, well, actually, let me write it first like 4 plus 4 times 99. Do the same thing over here. This is the same thing as plus 9. Let me do that magenta color. Plus 9 plus 9 times 9. 9 times 9. And then finally, I have this 8 right over here. And I can rearrange everything. These terms right over here, the 4 times 99 and then the 9 times 9. I can write over here 4 times 99. I'll write it with slightly different notation, plus the 9 times the 9. That's those two terms. And then we have the plus 4, plus 9, plus 9, plus 8. Plus 8. Well, can we now tell whether this is divisible by 3? Well, these terms, these first two terms, are definitely divisible by 3. This is divisible by 3 because 99 is divisible by 3 regardless of what we have over here. You don't even have to look at this. This is divisible by 3, so if you're multiplying, it's still going to be divisible by 3. This is divisible by 3, so if you're multiplying, this whole thing is still going to be divisible by 3. If you add two things that are divisible by 3, the whole thing is going to be divisible by 3. So all of this is divisible by 3. And if you had other digits here, you would have done the same exact thing. Instead of having 1 plus 99, you would have 1 plus 999, 1 plus 9,999, etc., etc. So the only thing you have to really worry about is this part right over here. You have to ask yourself, in order for this whole thing to be divisible by 3, this part is, well, if that part is, then this part, in order for the whole thing has to be divisible by 3, that also has to be divisible by 3. But what is this right over here? These are just our original digits, 498, 4, a 9, and an 8. We just have to make sure that when we take the sum, it's divisible by 3. So the only thing you have to really worry about, 9 in the tens, or distribute times 1 plus 9. And then finally this 8, that's in the ones place, that's just 8 times 1, or we could just write plus 8. Now, we can distribute this 4. This is 4 times...
plus 8. Okay.
Someone walks up to you on the street and says, 2,943. Quick, is this divisible by 9? It's a matter of life and death. And you could say, well, I can do this fairly quickly. To figure out whether it's divisible by 9, I just have to add up the digits and figure out if the sum of the digits is a multiple of 9, or whether it's divisible by 9. So let's do that. 2 plus 9 plus 4 plus 3. 2 plus 9 is 11. 11 plus 4 is 15. 15 plus 3 is 18. And 18 is definitely divisible by 9. So this is going to be divisible by 9. And even if you are unsure whether 18 is divisible by 9, you can apply the same rule again. 1 plus 8 is equal to 9. So that's definitely divisible by 9. And so the person can go save their lives, or whoever's life they were trying to save, with that information. But this might leave you thinking, well, that was nice and useful, but why did that work? Does this work for all numbers? Does it only work for 9? I don't think this works for 8 or 7 or 11 or 17. Why does it work for 9? And it actually also works for 3, and we'll think about that in a future video. And to realize that, we just have to rewrite 2,943. So the 2 in 2,943, it's in the thousands place. So we can literally rewrite it as 2 times 1,000. The 9 is in the hundreds place, so we can literally write it as 9 times 100. The 4 is in the tens place, so it's literally the same thing as 4 times 10. And then finally we have our 3 in the ones place. We could write it as 3 times 1, or just 3. This is literally 2,940 and 3. 2,943. But now we can rewrite each of these things, this 1,000, this 100, this 10, as the sum of 1 plus something that is divisible by 9. So 1,000 I can rewrite as 1 plus 999. 1 plus 999. I can rewrite 100 as 1 plus 99. 1 plus 99. I can rewrite 10 as 1 plus 9. And so 2 times 1,000 is the same thing as 2 times 1 plus 999. 9 times 100 is the same thing as 9 times 1 plus 99. 4 times 10 is the same thing as 4 times 1 plus 9. And then I have this plus 3 over here. But now I can distribute. I can say, well, this over here is the same thing as 2 times 1, which is just 2, plus 2 times 999. This thing right over here is the same thing as 9 times 1. Just to be clear what I'm doing, I'm distributing the 2 on that over the first parentheses, these first two terms. Then the 9 I'm going to distribute again. So it's going to be 9 times 1, plus 9 times 99. Plus 9 times 99. And then over...
Someone's knocking. Right, I'm right.
Over here, I forgot the plus sign right over here. I'm going to distribute the 4. 4 times 1, so plus 4. And then 4 times 9, so plus 4 times 9. And then finally I have this positive 3, or plus 3 right over here. Now I'm just going to rearrange this addition. So I'm going to take all the terms where I'm multiplying by 999. And I'm going to do that in orange. So I'm going to take this term, and this term right over here. And so I have 2 times 999, that's that there, plus 9 times 99, plus 4 times 9, plus 4 times 9. So that's those three terms. And then I have plus 2, plus 2, plus 9, plus 9, plus 4, plus 4, and plus 3. Plus 3. And this is interesting. This is just the sum of our digits. This is just what we did up here. And you might see where all of this is going. This orange stuff here, is this divisible by 9? Well, definitely. 999, that's divisible by 9. So anything that's multiplying by it is divisible by 9. So this is divisible by 9. This is definitely divisible by 9. 99, regardless of whether it was being multiplied by 9. Whatever is multiplying 99 is going to be divisible by 9, because 99 is divisible by 9. So this works out. And same thing over here. You're always going to be multiplying by a multiple of 9. So all of this business right over here is definitely going to be divisible by 9. And so in order for the whole thing, and all I did is I rewrote 2,943 like this right over here. In order for the whole thing to be divisible by 9, this part definitely is divisible by 9. In order for the whole thing the rest of this sum has to be divisible by 9 as well. So in order for this whole thing, all of this has to be divisible by 9.
Oh.
Someone walks up to you on the street and says, 2,943. Quick! This is 4 times 1 plus 4 times
I wonder
99.
what the comments are.
Someone walks.
It's pretty cool. Divisible, yeah, it's divisible by 5. No. Okay, let's see. We have 18, 15, 14. No. Oh, yes. Oh no, okay. We have 10, 19, 19, 21. No. Wait. Oh, it's actually by 3. Let's hear again. 10, 19, 27, 29. 2 plus 9 is 11. No. 4. No. Yes. Cool. Okay. Great. Factors and multiples.
Find all of the factors of 120. Or another way to think about it, find all of the whole numbers that 120 is divisible by. So the first one, that's maybe obvious, all whole numbers are divisible by 1. So we could write 120. It is equal to 1 times 120. So let's write a factors list over here. Factors.
122 times
Factors
60.
right here. So this is going to be our factors list over here. So we just found 2 factors. We said, well, is it divisible by 1? Well, every whole number is divisible by 1. This is a whole number.
5,
so 1 is a factor at the low end. 1 is a factor. That's its actual smallest factor. And its largest factor is 120. You can't have something larger than 120 dividing evenly into 120. 121 will not go into 120. So the largest factor on our factors list is going to be 120. Now let's think about others. Let's think about whether is 2 divisible into 120. So does 120 equal 2 times something? Well, when you look here, you immediately, or maybe you immediately recognize that 120 is an even number. Its ones place is a 0. As long as its ones place is a 0, 2, 4, 6, or 8, as long as it's an even number, the whole number is even, and the whole number is divisible by 2. And to figure out what you have to multiply by 2 to get 120, well, you can think of, well, 120 is 12 times 10. Or another way to think about it, it's 2 times 6 times 10, or 2 times 60. You could divide it out if you want. You could say, okay, 2 goes into 120. 2 goes into 1, no times. 2 goes into 12. 6 times 2 is 12. Subtract. You get 0. Bring down the 0. 2 goes into 0. 0 times 2 is 0. And you get no remainder there. So it goes 60 times. So we have 2 more factors right here. So we have the factors. So we've established, so the next lowest one is 2, and the next highest factor, if we're starting from the large end, is going to be 60. Now let's think about whether 3 is 120 equal to 3 times something. Well, we could just try to test and divide it from the get-go, but hopefully you already know the divisibility rule. To figure out if something is divisible by 3, you add up its digits, and if the sum is divisible by 3, we're in business. So if you take 120, so we're dealing with, so this is 1, let me do it over here, 1 plus 2 plus 0 Well, that's equal to 1 plus 2 is 3 plus 0 is 3. And 3 is definitely
There's something
divisible
weird flipping
by
right
3. So this is 120 is going to be divisible by 3. And to figure what that number that you have to multiply by 3 is, you could do it in your head. You could say, well, 3 goes into 12 4 times. And then let me just do it out just in case, just for those of you who want to see it worked out. 3 goes into 12 4 times. 4 times 3 is 12. You subtract. You're left with nothing here. You bring down this 0. 3 goes into 0 0 times. 0 times 3 is 0. Nothing left over. So it goes into it 40 times. 40 times. And the way to think of it in your head is this is the same thing as 12 times 10. 12 divided by 3 is 4. But this is going to be 4 times 10 because you have that 10 left over. Whatever works for you. Or you could just ignore the 0, divide by 3, you get a 4, and then put the 0 back there. Whatever works. So we have two more factors. At the low end, we have a 3. And at the high end, we have a 40. We have a 40. Now let's see if 4 is divisible into 120. Now, we saw the divisibility rule for 4 is you ignore everything beyond the tens place, and you just look at the last two digits. So if we're going to think about whether 4 is divisible, you just look at the last two digits. The last two digits are 20. 20 is definitely divisible by 4. So 120 will be divisible by 4. 4 is going to be a factor. And to figure out what we have to multiply 4 by to get 120, you could do it in your head. You could say 12 divided by 4 is 3. So 120 divided by 4 is 30. So we have two more factors, 4 and 30. And you can work this out long division if you want to make sure that this works out. So let's keep going. And then we have, let's see, what 120 is equal to, is 5 a factor? Is 5 times something equal to 120? Well, you can't do that simple. Well, first of all, we could just test, is it divisible? And
Yep.
120 ends with a 0. If you end with a 0 or a 5, you are divisible by 5. So 5 definitely goes into it. And let's figure out how many times. So 5 goes into 120. Doesn't go into 1. It goes into 12 2 times. 2 times 5 is 10. Subtract. You get 2. Bring down the 0. 5 goes into 20 4 times. 4 times 5 is 20. And then you subtract. And then you subtract, and you have no leftover, as we expect, because it should go in evenly. This number ends with a 0 or a 5. So 5, let me delete all this so we can have our scratch space to work with later on. So 5 times 24 is also equal to 120. So we have two more factors, 5 and 24. And let me clear up some space here, because I think we're going to be dealing with a lot of factors. So let me move this right here. So let me cut it, and then let me paste it. Move this over here so we have more space for our factors. So we have 5 and 24. Let's move on to 6. So 120 is equal to 6 times what? Now, to be divisible by 6, you have to be divisible by 2 and 3.
Yep.
Now, we know that we're already divisible by 2 and 3, so we're definitely going to be divisible by 6. And you should hopefully be able to do this one in your head. 5 was a little bit harder to do in your head. But 120, you could say, well, 12 divided by 6 is 2. And then you have that 0 there. So 120 divided by 6 would be 20. And you could work it out long division if you like. So 6 times 20 are two more factors. 6 times 20. Now, let's think about 7. Let's think about 7 here. 7 is a very bizarre number. And just to test it, you could think of other ways to do it. Let's just try to divide 7 into 120. 7 doesn't go into 1. It goes into 12 one time. 1 times 7 is 7. You subtract. 12 minus 7 is 5. Bring down the 0.
It's
7 goes
7.
into 50. 7 times 7 is 49. So it goes into it 7 times. 7 times 7 is 49. Subtract.
One
You
left
have a
over.
remainder. So it does not divide evenly. So 7 does not work. 7 does not work. Now let's think about 8. Let's think about whether 8 works. Let's think about 8. I'll do the same process. Let's take 8 into 120. And just as a little bit, well, let's just see, let's just work it out. And just as a little bit of a hint, well, I'll just work it out. 8 goes into 12. It doesn't go into 1, so it goes into 12 one time. 1 times 8 is 8. Subtract there. 12 minus 8 is 4. Bring down the 0.
Wow.
8 goes into 40 5 times. 5 times 8 is 40. And you're left with no remainder, so it goes evenly. So 120, let me get rid of that.
What's your trick?
120.
Not.
120 is equal to 8 times 15. So let's add that to our factor list. We now have an 8, and now we have a 15. Now, is it divisible by 9? Is 120 divisible by 9? To test that out, you just add up the digits. 1 plus 2 plus 0 is equal to 3. Well, that satisfies our 3 divisibility rule, but 3 is not divisible by 9. So our number will not be divisible by 9. So 9 will not work out. 9 does not work out. So let's move on to 10. Well, this is pretty straightforward. It ends in 0, so we will be divisible by 10.
10 times 12, yeah.
So let me write that down. 120 is equal to 10 times, and this is pretty straightforward, 10 times 12. This is exactly what 120 is. It's 10 times 12. So let's write those factors down. 10 and 12. And then we have one number left. We have 11. We don't have to go above 11 because we already went through 12, and we know that there aren't any factors above that because we were going in descending order. So we've really filled in all of the gaps. And you could try 11. We could try it by hand if you like. 11 goes into 120. And you know it, if you know your multiplication tables through 11 that this won't work, but I'll just show you. 11 goes into 12 one time. 1 times 11 is 11. Subtract 1. Bring down the 0. 11 goes into 10. 0 times 11 is 0. You're left with a remainder of 10.
Yeah.
So 11 goes into 20. 10 times with the remainder 10 definitely does not go in evenly. So we have all of our factors here. 1, 2, 3, 4, 5, 6, 8, 10, 12, 15, 20, 24, 30, 40, 60, and 120. And we're done.
Oh, crap. I think I want to take a rest for a bit. Alright, I'm back. I slept. And now I'm gonna continue where I left off. So finding factors. Let's just take a quick look. What was this all about? I think this was the one with factors of 120, right? Why can't I play? What the hell?
You get 2.
Yeah,
Satisfies a remainder of
okay, cool.
10.
So finding factors and multiples. Okay, cool. Let's go. My audio is working, but it's sad. Can Sal be heard? And why isn't this playing? It's not playing. I have internet. Okay, so let's try to restart the browser. I mean the tab. Or why not? How about the whole browser? We'll start with the browser. Share notifications. Watch part for 15 consecutive days. Holy crap. Display.
Which of the following numbers is a factor of 154? So a number is going to be a factor of 154 is if we can divide that number into 154 and not have a remainder. Or another way of thinking about it, a number is a factor of 154 if 154 is a multiple of that number.
Okay.
So let's look at each of these and see which of these we can rule out or say is a factor. So does 3 divide evenly into 154? Or another way of thinking about it is 154 a multiple of 3?
No.
Well, you'll later learn that you can actually test whether something is divisible by 3 by adding up the digits, and if that's divisible by 3, then it's going to be divisible by 3. And so you see here 1 plus 5 is 6, 6 plus 4 is 10. 10 is not divisible by 3. But if you didn't want to do that little trick, and we have other videos where we go into more detail about that trick, you can actually just divide 3 into 154. 3 doesn't go into 1. It does go into 15 5 times. 5 times 3 is 15. Subtract.
14, yeah,
then we have 0. Then you bring down a 4. 3 goes into 4 one time. 1 times 3 is 3. Subtract. and you have a remainder of 1. So 3 is clearly not a factor of 154. So we can rule that out. Now what about 5? Well, any multiple of 5 is either going to have a 5 or a 0 in the ones place. You see that if 5 times 1 is 5, 5 times 2 is 10, 5 times 3 is 15, 5 times 4 is 20. You either have a 5 or a 0 in the ones place. This does not have a 5 or a 0 in the ones place, so it's not going to be divisible by 5. 5 is not a factor. 154 is not a multiple of 5.
True.
Now 6 is interesting. You could do the same thing. You could try to divide 6 into 154. But if something is divisible by 6, it's definitely going to be divisible by 3 as well, because 6 is divisible by 3. So we can immediately rule this one out as well. Because 154 is not divisible by 3, it's also not going to be divisible by 6. And you could try it out if you like. And we can make the same argument for 9. If something is divisible by 9, it's going to be divisible by 3, because 9 is divisible by 3. Well, it's not divisible by 3, so we're going to rule out 9 as well. So we've ruled out everything. It looks like 14 is our only option, but let's actually verify it. Let's actually divide 14 into 154. 14 doesn't go into 1. It goes into 15 exactly one time. 1 times 14 is 14. We subtract. We get 1. Bring down the 4. 14 goes into 14 one time. 1 times 14 is 14. And, of course, we have no remainder. So 14 goes into 154 exactly 11 times, or 11 times 14 is 154. 154 is a multiple of 14. Cool. Let's do one more. Which of the following numbers is a multiple of 14? So now we have 14 and we're trying to think of its multiples. So there's two ways of doing this. You could go number by number and try to divide 14 into them, or we could just try to figure out what all of the multiples of 14 actually are. So let's try to do that. Let's try to do that second technique. 14 times 1. 14 times 1 is 14. You add another 14. 14 times 2 is 28. Add another 14. Let's see, you add 10, you get to 38. Then you add 4 more, you get to 42. Then you add another 14. I haven't seen any of these numbers show up yet. Add another 14 to this, you get to 56. Still not quite there. Add another 14. Let's see, if you add 4, you get to 60, and then you have to add the 10. So then you get to 70. And it looks like we have found one of these numbers. 70 is a multiple of 14. 14 times 1, 2, 3, 4, 5. 14 times 5 is 70.
Oh, just one of those, I thought.
Yeah, found one of these numbers. 70 is a multiple of 14.
You didn't even check
14 times 1, 2, 3, 4, 5. 14 times 5 is 70.
Okay. Factors are real numbers that can evenly divide another number. Okay, wait, what? So there's 4 rows with 3 dots. We already discovered that the factors of 3 with 3 rows. Okay, once figured all out the ways that are going to range, we can look at the number of rows and the number of dots in each row with the factors of 12. 1, 2, 2, 6, 3, 3, 4. We can make 12 with a row of 5 and a row of 7. So are 5 and 7 factors of 12? No. Dots are not divided into equal sized groups. Cool. Which of the following arrangements are possible for 18 dots? 1 row of 18, 2 dots of 19. Cool. What are the factors of 18? 2, 3, not 4, not 5, 6, 9, 18. Cool. Check. Finding factors without pictures. We can find the factors for 16 without drawing dots by thinking numbers that will divide into 16 evenly. 1 is a factor of 16 because 1 can be divided into 2 is a factor of 16 because 2 can be divided. 4 is a factor of 16 because 4 can be divided. The following okay. Numbers like 3 or 5 are not because they cannot be evenly divided. Use number to determine which of the following numbers are factors of 25. 1. No. No. Yes. 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 A factor hints. Every number has one as a factor. Every number as itself is a factor. Okay. Factor pairs. Two numbers that we multiply together to get a certain products are called factor pairs. To get the product of 8 and 2. So factor pairs for 8 are 1, 8, and 2, 4. Okay. Arranging dots in equal size groups help us to see the factors always come in pairs. One factor in the... Okay, let's find the factors now. And we are looking for two whole numbers that we can multiply to get 90. We start with 1 because we start 1 and 90 is also factorizations. 2 and 10, yep. 3, 0, no. 4 is... Yes, 4 times 5, so 4, 5 are factor pairs. The next counting number is 5. Since 5 already appears in the list, we now have countable factors. Factors pairs for 20. Match the factor pairs for 40. 45. Yeah, okay, cool. But what? Yeah. Show answer. Stored in the factors. Nope. Okay. Oh shit. I thought like just one answer. Oh my gosh. The list shows multiples of 8. Which of the following numbers are multiples of 6? 32, no. 42 and 66. Picturing multiples. The following pictures show multiples of a 4. The next box will include the next multiple. How many later box will 16? How the following multiples relate? It's also a multiple of 7. Use the number 30 and 4 to complete the following sentences. 32 is a factor of 4. Oh, wait, what? 4 is a factor of 32. And 4 is a multiple of 30. Is that supposed to be? What the fuck? What am I supposed to say? So the other way around? Doesn't make sense. 4. Use the numbers 32 and 4 to complete the following sentences. Wait, what? What is this supposed to even mean? They're both factors of 28. 32, 4 is a factor of 32. Right? It's 8. 8 is a multiple of 32. Is that what it's supposed to say? I mean 30 is... Oh shit, I think I got it the other way around. 32 is a multiple of 4, like that? Okay, cool. Shit. Practice factors. Which of the following are factors of 10? 2, 5, 10. Which of the following multiples of 10? 2, 5, 10. Oh shit, multiples of 10. Oh fuck. Factors. No. Oh shit. I got debated. We know that 9 times 6 is 54. Which of the following statements are also true? 9 is a factor of 6, no? 54 is a multiple of 6. 9 is a factor of 54. 9 is a multiple of 6. No. Factors and multiples are used in solving problems about side lengths and areas of rectangles. A rectangle is an area of 50 square centimeters. Which of the following could be the side lengths of the rectangle? 225, 510. Mr. Trimble is putting out 36 chocolate chip cookies for the students in his art club. If he arranges the cookies in 3 rows, there will be 12 in each row. If he arranges cookies in 4 in 9 rows, okay. I'm done with this. Okay. Uh, oh, 16. Fuck. A multiple is a number that results when multiplied by another. 40 is a multiple of 8. 8 is a factor, 5 is a factor. Multiple of 4. I'm not gonna go to the quiz. I still have practices. Identify factors. Which equation shows that 9 is a factor of 97? 72 divided by 9 is 8, right? Okay. Factors of 36. Oh shit, that's insanely a lot. 1, 36, 2, 18, 3, 6, 9. Yeah, we got 3. And 12, I guess. Then for 4 and 9. Yeah, the next thing's gonna be like 10. But no, 11 says no. So we have 1, 36, 2, 3, 4, 12. And 6 as well. 6 times 6, dude. And 4 and 5 is not, but 6. Yeah, and 7, but 8 is not. Which of the following numbers is a factor of 63? It's gonna be 8. Oh wait, no. Let's show 3. It's gonna be 9. Which equation shows that 8 is a factor of 32? 8 times 4 is 32, right? Okay. But one answer only, okay. Please solve the factors of 56. $28. Yeah. And it's divisible by 3. 11, so no. How about 4? Yeah. 4 and 14. For 6, no. 7 and 8. Which of the following number is a factor of 49? 7 is. Which equation shows that 6 is a factor of 18? 6 times 3. Or 6 times 3. Wait, what? Yeah, 6 times 3, dude. Where's that? Or we could do 18 divided by 6. Which would evenly give us a nice number there. Identify multiples. Which of the following shows only multiples of 6? 12, 18, and 48 are 6. Which equation best shows that 55 is a multiple of 11? 11 times 5. 5. Just 1, okay. Which of the following number is a multiple of 7? 28 definitely is. Which of the following shows only multiples of 10? Okay, that's pretty good. But then when it comes to quiz, I'm gonna make a mistake, surely. I hate it. 5 questions only, what? Shade all multiples of 8 on the 100 chart. What mistake did France make? Okay, let's see. 8, 16, 24, 32, 40, 48, 56, 64, 72, 80, 88, 96. Wow, it's pretty good. I think it did not make any mistake at all. What does that even mean, Francie? Shaded 8, but multiples are always greater than that. No. 8 is included. No? No, okay. Is divisible by 10? Yes. Factors of 24, we have like 124, we have 212, 6, yeah, 3, 8, I guess, and then 4, 6. Yeah, I guess it's the only factors of it. 1, 2, 3, 1, 2, 3, 4. Okay. Which equation best shows that 45 is a multiple of 15? 45 is a multiple of 15 because 45 divided by 3 is 15. We know that 6 times 7 is 42. Which of the following statements is also true? 6 is a factor of 42. 42 is a multiple of 7. Wait. No. Oh. Great, got first quiz. Okay, I'm recording. 20 minutes in. Okay, cool. Prime numbers. Holy shit, it's gonna be hard.
In this video, I want to talk a little.
I'm gonna grab a drink. Sec. Alright, I'm back, boys. I'm back.
Talk a little bit about what it means to be a prime number. And what you'll see in this video, or what you'll hopefully see in this video, is it's a pretty straightforward concept. But as you progress through your mathematical careers, you'll see that there's actually fairly sophisticated concepts that can be built on top of the idea of a prime number. And that includes the idea of cryptography, and maybe some of the encryption that your computer uses right now could be based on prime numbers. If you don't know what encryption means, don't have to worry about it right now. Just need to know that prime numbers are pretty important. So I'll give you a definition, and the definition might be a little confusing, but when we see it with examples, it should hopefully be pretty straightforward. So a number is prime if it is a natural number, and a natural number, once again, just as an example, these are like the numbers 1, 2, 3. So essentially the counting number starting at 1, or you could say the positive integers. It is a natural number divisible by exactly two numbers, or two other natural numbers. Actually, I shouldn't say two other. I should say two natural numbers. So it's not two other natural numbers, divisible by exactly two natural numbers. One of those numbers is itself itself, and
And
the
the
other
other
one
one
is
is
1. Those are the two numbers that it is divisible by. And that's why I didn't want to say exactly two other natural numbers, because one of the numbers is itself. And if this doesn't make sense for you, let's just do some examples here and figure out if numbers are prime or not. So let's start with the smallest natural number, the number 1. So you might say, well, look, 1 is divisible by 1, and it is divisible by itself. You might say, hey,
prime.
1 is a prime number. But remember, part of our definition, it needs to be divisible by exactly two natural numbers. 1 is divisible by only one natural number, only by 1. So 1, although it might be a little counterintuitive, is not 1
Oh, that's sad.
is not prime. Let's move on to 2. Let's move on to 2. So 2 is
I
divisible
mean,
by
exactly two natural numbers, but one divided by one, those are two natural numbers, right? Wait, what?
1 and by 2, and not by any other natural numbers. So it seems to meet our constraint. It has two, it's divisible by exactly two natural numbers, itself, that's 2 right there, and 1. So 2 is prime. So 2 is prime. And I'll circle the prime numbers. I'll circle them. Well, actually, let me do it in a different color since I already used that color for the. Well, I'll just circle them. I'll circle the numbers that are prime. Now let's 3. And 2 is interesting because it is the only even number that is
That's
prime. If you think about it, any other even number is also going to be divisible by 2 above and beyond 1 and itself. So it won't be prime. We'll think about that more in future videos. Let's try out 3. Well, 3 is definitely divisible by 1 and 3. And it's really not divisible by anything in between. It's not divisible by 2. So 3 is also, it's also a prime number. Let's try 4. And I'll switch to another color here. Let's try 4. Well, 4 is definitely divisible by 1 and 4. But it's also divisible by 2. 2 times 2 is 4. It's also divisible by 2. So it actually has, it's divisible by 3 natural numbers, 1, 2, and 4. So it does not meet our constraint for being prime. Let's try out 5. So 5 is definitely divisible by 1. It's not divisible by 2. It's not divisible by 3. It's not divisible by 4. Exactly divisible by 4. You could divide them into it, but you would get a remainder. But it is exactly divisible by 5, obviously. So once again, it's divisible by exactly two natural numbers, 1 and 5. So once again, 5 is prime. Let's keep going just so that we see if there's any kind of a pattern here. And then maybe I'll try a really hard one that tends to trip people up. So let's try the number 6. It is divisible by 1. It is divisible by 2. It is divisible by 3. Not 4 or 5, but it is divisible by 6. So it has 4 natural number factors, I guess you could say it that way. And so it does not have exactly two numbers that it is divisible by. It has 4. So it is not prime. Let's move on to 7. 7 is divisible by 1.
Skip the
Not 2, not 3, not
even
4, not 5,
numbers.
not 6, but it's also divisible by 7. So 7 is prime. I think you get the general idea here. How many natural numbers, numbers like 1, 2, 3, 4, 5, the numbers that you learned when you were 2 years old, not including 0, not including negative numbers, not including fractions and irrational numbers and decimals and all of the rest, just regular counting positive numbers. If you have only 2 of them, if you're only divisible by yourself and 1, then you are prime. And the way I think about it, if we don't think about the special case of 1, prime numbers are kind of these building blocks of numbers, that you can't break them down anymore. They're almost like the atoms. If you think about what an atom is, or what people thought atoms were when they thought it was kind of the thing that you couldn't divide anymore. We now know that you could divide atoms, and actually if you do, you might create a nuclear explosion. But it's the same idea behind prime numbers. In theory, well, and in prime numbers, it's not theory. We know you can't break them down into products of smaller natural numbers. Things like 6, you could say, hey, 6 is 2 times 3. You can break it down. And notice, we can break it down as a product of prime numbers. We've kind of broken it down into its parts. 7, you can't break it down anymore. All you can say is that 7 is equal to 1 times 7. And in that case, you really haven't broken it down much. You just have the 7 there again. 6, you can actually break it down. 4, you can actually break it down as 2 times 2. Now, with that out of the way, let's think about some larger numbers and think about whether those larger numbers are prime. So let's try 16. So clearly, any number is divisible by 1 and itself. So any number, any natural number you put up here is going to be divisible by 1 and 16. So you're always going to start with 2. So if you can find anything else that goes into this, then you know you're not prime. And 16, you could have 2 times 8. You can have 4 times 4. So it's got a ton of factors here, above and beyond just the 1 and 16. So 16 is not prime. What about 17? 1 and 17 will definitely go into 17. 2 doesn't go into 17. 3 doesn't go. 4, 5, 6, 7, 8, 9, 10, 11. None of those numbers. Nothing between 1 and 17 goes into 17. So 17 is prime. And now I'll give you a hard one. This one can trick a lot of people.
51,
What about
right?
51?
Holy shit.
Is 51 prime?
No, it's not.
Is 51
17
prime?
times 3, man.
And if you're interested, maybe you could pause the video here and try to figure out for yourself if 51 is a prime number. If you can find anything other than 1 or 51 that is divisible into 51. It seems like, wow, this is kind of a strange number. You might be tempted to think it's prime, but I'm now going to give you the answer. It is not prime because it is also divisible by 3 and 17. 3 times 17 is 51. So hopefully that gives you a good idea of what prime numbers are all about, and hopefully we can give you some practice on that in future videos or maybe some of our exercises. In this video, I want to talk a little bit about determine whether the following numbers are prime, composite, or neither. So just as a bit of review, a prime number is a natural number, so one of the counting numbers, 1, 2, 3, 4, 5, 6, so on and so forth, that has exactly 2 factors. So its factors are 1 and itself. 1 and itself. So an example of a prime factor is 3. There's only 2 natural numbers that are divisible into 3. 1 and 3. Or another way to think about it is the only way to get 3 as a product of other natural numbers is 1 times 3. So it only has 1 and itself. A composite number is a natural number that has more than just 1 and itself as factors. And we'll see examples of that. And neither, we'll see an interesting case of that in this problem. So first, let's think about 24. So let's think about all of the, I guess you could think of it as the natural numbers or the whole numbers, although 0 is also included in whole numbers. Let's think of all of the natural counting numbers that we can actually divide into 24 without having any remainder. We'd consider those the factors. Well, clearly it is divisible by 1 and 24. In fact, 1 times 24 is equal to 24. But it's also divisible by 2. It's also divisible by 2. 2 times 12. 2 times 12 is 24, so it's also divisible by 12. And it is also divisible by 3. 3 times 8 is also equal to 24. And even at this point, we don't actually have to find all of the factors to realize that it's not prime. It clearly has more factors than just 1 and itself. So then it is clearly going to be composite. Composite.
Just for
This
the kicks,
is going to be
4 and
composite.
6.
Now, let's just finish factoring it just since we started it. It's also divisible by 4, and 4 times 6 had just enough space to do that. 4 times 6 is also 24. So these are all of the factors of 24, clearly more than just 1 and 24. Now let's think about 2.
Oh,
Well,
one is neither.
the non-zero whole numbers that are divisible into 2. Well, 1 times 2 definitely works, 1 and 2. But there really aren't any others that are divisible into 2. And so it only has 2 factors, 1 and itself. And that's the definition of a prime number. So 2 is prime. 2 is prime. And 2 is interesting because it is the only even prime number. Only even. Only even prime number. And that might be common sense to you because by definition, an even number is divisible by 2. An even number is divisible by 2. So 2 is clearly divisible by 2. That's what makes it even. But it's only divisible by 2 and 1. So that's what makes it prime. But anything else that's divisible, that's even, is going to be divisible by 1 itself, and 2. Any other number that is even is going to be divisible by 1 itself and 2. So by definition, it's going to have 1 in itself and something else. So it's going to be composite. So 2 is prime. Every other even number other than 2 is composite. Now here's an interesting case. 1. 1 is only divisible by 1. So it is not prime, technically, because it only has 1. It only has 1 as a factor. It does not have 2 factors. 1 is itself, but in order to be prime, you have to have exactly 2 factors. 1 has only 1 factor. In order to be composite, you have to have more than 2 factors. You have to have 1, yourself, and some other things. So it's not composite. So 1 is neither prime nor composite. 1 is neither. And then finally, we get to 17. 17 is divisible.
Prime.
17 is divisible by 1 and 17. It's not divisible by 2, not divisible by 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, or 16. So it has exactly 2 factors, 1 and itself. So 17 is once again, 17 is prime.
Didn't read any composite. Okay. $19. No. Wow. Okay. Oh. What? All odd numbers are prime. Oh no, shit. It's prime can be even. Oh, that number 2, right? Holy shit. Hey, prime numbers are numbers with exactly 2 factors. Uh, 61 is 97 could be. I think 61 is a prime. Could be either of these two. Let's see, 87. It's gonna be 15. So it's gonna be divisible by 3, right? 87. What's 87 divided by 3? 29. Wow. It's very exotic. It's prime. 37 could be. What are composite numbers? Why did the article repeat it itself? So I guess these are prime numbers. 29, 41. Composite. 35 is composite. Okay. Identifying prime numbers. Wow, this is hard. 3. I guess 71's prime. It's a prime. And one's prime. Wait! It's prime. Oh shit, it's 5, right? Fuck. 90? 91? Okay, I don't know. It's prime. Maybe I was too hasty. There's 7. Prime. 73 is prime. No, 53 is prime. 7's prime. 11's prime. 47's prime. Or 87? No, I'll take 7. 17's prime. Identify composite numbers, okay? It's composite. It is composite. First 49. Ah, this is hard. This is 73. Or 49. Either of these two, right? Let's see. I mean, if I do 24, if 48, 48. Oh, 49 though. I think 73 is the answer here. But 49, let's see. I think. What numbers from circle to 9? Yo, this is hard. Okay. If it's 3, 13 is 39. What about something equal to 5 in its end? 5, 7. 7. Oh shit, 49 is 7 times 7. Which means it's the composite one. Holy fuck. I'm looking for composite, not prime. Fuck, I selected the prime. Composite. Insanely hard, but it's B. It's composite. It's a... Holy shit. 12. 43. No, 27. I check for prime again. What the fuck? Which of this number is composite? It's composite. Be 12. Fuck, I made so much mistake. I hate it. Which of this number is composite? Say 99. It's composite. No, no, no. Yes, it's composite. Which number is composite? 33. 87. Yeah. 79 radio. 16. No, 10. Yo, this is hard. Could be 7, could be 91. Could be. This is surely a prime, 79 or 91. Just the, it was 79, pretty sure. Seven times 11, 77. 8 times 8, 64. 8 times 72. Whoa. What are the factors of... Yo, this is hard. This is 16. Right. It's not by 2, no. By 3, no. 10, 16, how about 4? No, not as well. 4, 5, no. 6. Is it possible by 6? No. How about this one? 66, no, not as well. How about 7? 70, 77, no. Oh, this is divisible by 7. 70 plus 21, right? Which means this is the answer. I selected the prime again. I'm a fucking idiot. Which of these numbers is composite? Oh, I hate myself so much. I don't mind just guessing that this is right. And I'm so annoyed right now. Numbers is composite. 69. Wow, I'm an idiot. I'm getting confused. Only prime numbers. Oh my god. 73? 75 is a composite number. It looks like it. Prime 10. It's not prime. All prime, right? Oh fuck, I could be wrong. Wow, cool. 7397 are prime. Sean tried to shade only composite number. John is correct. To try to debate people with 51. Okay, prime factorization.
Write the prime factorization of 75. Write your answer using exponential notation. So we have a couple of interesting things here. Prime factorization, and they say exponential notation. We'll worry about the exponential notation later. So the first thing we have to worry about is what is even a prime number. And just as a refresher, a prime number is a number that's only divisible by itself and 1. So examples of prime numbers, let me write some numbers down. Prime, not prime. Not
So I guess
prime.
355.
So 2 is a prime number. It's only divisible by 1 and 2. 3 is another prime number. Now 4 is not prime. 4 is not prime because it's divisible by 1, 2, and 4. We could keep going. 5, well, 5 is only divisible by 1 and 5. So 5 is prime. 6 is not prime because it's divisible by 2 and 3. I think you get the general idea. You move to 7. 7 is prime. It's only divisible by 1 and 7. 8 is not prime. 9, you might be tempted to say is prime, but remember, it's also divisible by 3. So 9 is not prime. Prime is not the same thing as odd numbers. Now, if you move to 10, 10 is also not prime, divisible by 2 and 5. 11, it's only divisible by 1 and 11. So 11 is then a prime number. And we could keep going on like this. People have written computer programs looking for the highest prime and all of that. So now that we know what a prime is, like this, people have written computer programs looking for the highest prime and all of that. So now that we know what a prime is, a prime factorization is breaking up a number like 75 into a product of prime numbers. So let's try to do that. So we're going to start with 75, and I'm going to do it prime numbers. Breaking up a number like 75 into a product of prime numbers. So let's try to do that. So we're going to start with 75, and I'm going to do it using what we call a factorization tree. So we first try to find just the smallest prime number that will go into 75. Now, the smallest prime number, 2. Does 2 go into 75? Well, 75 is an odd number, or the number in the ones place, this 5 is an odd number. 5 is not divisible by 2, so 2 will not go into 75. So then we could try 3. Does 3 go into 75? Well, 7 plus 5 is 12. 12 is divisible by 3, so 3 will go into it. So 75 is 3 times something else. And if you've ever dealt with change, you know, if you have 3 quarters, you have 75 cents. Or if you have 3 times 25, you have 75. So this is 3 times 25. And you could multiply this out if you don't believe me. Multiply out 3 times 25. Now, is 25 divisible by, you can give up on 2 if now, and you could multiply this out if you don't believe me. Multiply out 3 times 25. Now, is 25 divisible by, you can give up on 2. If 75 wasn't divisible by 2, 25 is not going to be divisible by 2 either. But maybe 25 is divisible by 3 again. So if you take the digits 2 plus 5, you get 7. 7 is not divisible by 3, so 25 will not be divisible by 3. So we keep moving up. 5. Is 25 divisible by 5? Well, sure. It's 5 times 5. So 25 is 5 times 5. And we're done with our prime factorization because now we have all prime numbers here. So we can write that 75 is 3 times 5 times 5. So 75 is equal to 3 times 5 times 5. We could say it's 3 times 25. 25 is 5 times 5. 3 times 25. 25 is 5 times 5. So this is a prime factorization, but they want us to write our answer using exponential notation. So that just means if we have repeated primes, we can write those as an exponent. So what is 5 times 5? 5 times 5 is 5 multiplied by itself 2 times. This is the same thing as 5 to the second power. So if we want to write our answer using exponential notation, we could say this is equal to 3 times 5 to the second power, which is the same thing as 5 times 5.
5 to the second
We're asked, what is the prime factorization of
It's not.
36? Let me get my little scratch paper out. So the prime factorization of 36. So let's start with the smallest prime number we know, and that is 2. And think about, does 2 go into 36? Well, sure it does. 36 is 2 times 18, so we can write that down. 36 is 2 times 18. So now we have 36 as a product of a prime number, and 18 is clearly a composite number. It has factors other than 1 and 18. So let's try to factor this further. So is this divisible by 2? Sure. 18 is 2 times 9. 2 times 9. So now 9 is a composite number that we haven't fully factored. Obviously, the 2's are both prime. 9 is not divisible by 2, but it is divisible by 3. 9 is 3 times 3. So we can say that 36 is equal to 2 times 2 times 3 times 3. This is its prime factorization. All of these numbers are prime. So now let's input that. Let's input that into, to make sure we got it right. 2 times 2 times 3 times 3. And you can check yourself. If you have the product of numbers that are all prime, and the product actually is 36, you have successfully prime factorized the number. Let's do a couple more of these. What is the prime factorization of 30? So I'll get my scratch paper out again. So we'll do the same process. So 30, well, it's divisible by 2, so we can write that as 2 times 15. 15 isn't divisible by 2, but it is divisible by 3. It's the same thing as 3 times 5. And both 3 and 5 are prime numbers. They are only divisible by 1 and themselves. So the prime factorization of 30 is 2 times 3 times 5. Let's enter that in. So it is 2 times 3 times 5. Let's do one more of these. What is the prime factorization of 73? Now 73 is interesting. It looks, 73, I'll get my scratch paper out for this. We could try to factor 73. So you might try 2. Well, this is clearly an odd number, so 2 isn't going to be divisible into 73. You might try 3. You would immediately see, well, 3 is divisible into 72. If you divide into 73, you have a remainder of 1. 4 isn't divisible. Well, 4 isn't a prime number, so we wouldn't even try. 5 isn't divisible into 73. It doesn't end in a 5 or a 0. 7 is not divisible into 73. 7 goes into 70, so you'd have a remainder of 3. 11 isn't divisible into 73. It's divisible into 66 or 77, so not 73. So it looks, as I test more and more numbers, it doesn't look like there's any easy thing that divides into 73. So I'm willing to go with 73 itself is a prime number. So this is its prime factorization. It's just 73. So let's write that down. So the answer here, let's just write 73. And you don't want to write 1 times 73 because 1 is not a prime number. You just want to remember it only has one factor itself. A prime number has 2 factors, 1 and itself, 2 different prime factors, 1 and itself is not 1. So we just want to write prime numbers here. 73 is a prime number. Let's check our answer. And we got it right.
In this video, I want to do a bunch of example problems that show up on standardized exams and definitely will help you with our divisibility module because it's asking you questions like this. All numbers, and this is just one of the examples, all numbers divisible by both 12 and 20 are also divisible by. And the trick here is to realize that if a number is divisible by both 12 and 20, it has to be divisible by each of these guys' prime factors. So let's take their prime factorization. The prime factorization of 12. Let's see, 12 is 2 times 6. 6 isn't prime yet, so 6 is 2 times 3. So that is prime. So any number divisible by 12 needs to be divisible by 2 times 2 times 3. So its prime factorization needs to have a 2 times a 2 times a 3 in it. Any number that's divisible by 12. Now, any number that's divisible by 20 needs to be divisible by, let's take its prime factorization. 2 times 10. 10 is 2 times 5. So any number divisible by 20 needs to also be divisible by 2 times 2 times 5. Or another way of thinking about it, it needs to have two 2's and a 5 in its prime factorization. Now, if you're divisible by both, you have to have two 2's, a 3, and a 5. Two 2's and a 3 for 12, and then two 2's and a 5 for 20. And you can verify this for yourself, that this is divisible by both. Obviously, if you divide it by 20, let me do it this way. Dividing it by 20 is the same thing as dividing it by 2 times 2 times 5. So you're going to have the 2's are going to cancel out, the 5's are going to cancel out. You're just going to have a 3 left over. And if you were to divide it, so it's clearly divisible by 20. And if you were to divide it by 12, if you divide it by 12, you divide it by 2 times 2 times 3. This is the same thing as 12. And so these guys would cancel out, and you would just have a 5 left over. So it's clearly divisible by both. And this number right here is 60. It's 4 times 3, which is 12, times 5. It's 60. This right here is actually the least common multiple of 12 and 20. Now, this isn't the only number that's divisible by both 12 and 20. You could multiply this number right here by a whole bunch of other factors. I could call them A, B, and C. But this is kind of the smallest number that's divisible by 12 and 20. Any larger number will also be divisible by the same things as this smaller number. Now, with that said, let's answer the questions. All numbers divisible by both 12 and 20 are also divisible by, well, we don't know what these numbers are, so we can't really address it. They might just be ones, or they might not exist, because the number might be 60. It might be 120. Who knows what this number is? So the only numbers that we know can be divided into this number, well, we know 2 can be. We know that 2 is a legitimate answer. 2 is obviously divisible into 2 times 2 times 3 times 5. We know that 2 times 2 is divisible into it, because we have the 2 times 2 over there. We know that 3 is divisible into it. We know that 2 times 3 is divisible into it. So that's 6. Let me write these. This is 4. This is 6. We know that 2 times 2 times 3 is divisible into it. I could go through every combination of these numbers right here. We know that 3 times 5 is divisible into it. We know that 2 times 3 times 5 is divisible into it. So in general, you can look at these prime factors, and any combination of these prime factors is divisible into any number that's divisible by both 12 and 20. So if this was a multiple choice question, and the choices were 7 and 9 and and 12 and and 8, you would say, well, let's see, 7 is not one of these prime factors over here. 9 is 3 times 3. So I need to have two 3's here. I only have one 3 here. So 9 doesn't work. 7 doesn't work. 9 doesn't work. 12 is 4 times 3. Or another way to think about it, 12 is 2 times 2 times 3. Well, there is a 2 times 2 times 3 in the prime factorization of this least common multiple of these two numbers. So this is a 12. So 12 would work. 8 is 2 times 2 times 2. You would need 3 2's in the prime factorization. We don't have 3 2's. So this doesn't work. Let's try another example just so that we make sure that we understand this fairly well. So let's say we want to know, we ask the same question. All numbers divisible by, let me think of two interesting numbers. All numbers divisible by 12 and let's say 9, and I don't know, let's make it more interesting. 9 and 24 are also divisible by. And once again, we just do the prime factorization. We essentially think about the least common multiple of 9 and 24. You take the prime factorization of 9, it's 3 times 3, and we're done. Prime factorization of 24 is 2 times 12. 12 is 2 times 6. 6 is 2 times 3. So anything that's divisible by 9 has to have a 9 in its factorization, or if you did its prime factorization, it would have to be a 3 times 3. Anything divisible by 24 has got to have a 3 2's in it. So it's got to have a 2 times a 2 times a 2. And it's got to have at least one 3 here. And we already have at least one 3 from the 9. So we have that. So this number right here is divisible by both 9 and 24. And this number right here is actually 72. This is 8 times 9, which is 72. So if the choices for this question, let's assume that it was multiple choice. Let's say the choices here were 16, 27, 16, 27, 5, 11, and 9. So 16, if you were to do its prime factorization, is 2 times 2 times 2 times 2. It's 2 to the fourth power. So you would need 4 2's here. We don't have 4 2's over here. I mean, there could be some other numbers here, but we don't know what they are. These are the only numbers that we can assume are in the prime factorization of something divisible by both 9 and 24. So we can rule out 16. We don't have 4 2's here. 27 is equal to 3 times 3 times 3. So you need 3 3's in the prime factorization. We don't have 3 3's. We only have 2 of them. So once
5
again,
is not.
cancel that
11
out.
is not.
5,
9 is
5's a
the
prime
only
number. There are
one.
no
Here
5's
is
here.
3.
Rule that out. 11, once again, prime number. No 11's here. Rule that out. 9 is equal to 3 times 3. And actually, I just realized that this is a silly answer because obviously all numbers divisible by 9 and 24 are also divisible by 9. So obviously 9 is going to work, but I shouldn't have made that a choice because that's in the problem. But 9 would work. And what also would work is if we had if 8 was one of the choices. Because 8 is equal to 2 times 2 times 2. And we have a 2 times 2 times 2 here. 4 would also work. 4 would also work. That's 2 times 2. 6 would work, since that's 2 times 3. 18 would work, because that's 2 times 3 times 3. So anything that's made up of a combination of these prime factors will be divisible into something divisible by both 9 and 24. Hopefully that doesn't confuse you too much.
Doesn't. What's the prime factorization of 23? Oh. Oh, okay. I think 23 is a prime already itself. 33 is now. Times 11, right? Whoops. Whoa, wait, what? Oh. Enter your answers a product of, I think 97 is already a prime by itself. 91 is 81 is like 9 times 9. Three. Is it supposed to be like this? So weird. No, let's just try. Times 3 times 3 times 3. 3. Cool, okay. 31, I think 31's prime. 92 is not prime, so we have 46, right? Uh, 4, 92, okay. 23, and yeah, I guess 23 is already prime. 2 times 2 times 2. Oh shit, I'm not sick. Okay. 43 is already prime, I believe. Okay, quiz 2. How long? Oh. Okay. I think I need more like 30 more minutes for me to actually be done with it. Yeah. Okay. Which of the following describes a number shaded on the 100 chart? The shaded numbers are all prime. What is the prime factorization of 91? Oh shit, 91 is already a prime. or not actually. Set 37. No. What if we do 27 times 3? That's gonna be like 1, 2, 6, 7. I'll say the 1, dude. 6, 7, 8. Yo, 91 is a prime. Oh, apparently not. Okay, cool. Third times 3 is not, so maybe 27 was actual. No, not really. Seven. Yo, this is hard. 4 and 5 is 100. 4 and 37 is not, 27 is not enough. 37 is too much. But something that will give me 1. Over there. It's definitely not by 3, not by 3. Something alongside of probably 6 and no, not really. Okay, not by 4, not by 7 times 7 is 49. Yo, this is insanely hard. Oh my god. This 7 is not prime? What the fuck? It's 12, something by 3. $19? Fucking kidding me? Wow. Okay, I agree. Oh yeah, didn't level down. Cool. If I made 2 mistakes, I think that's the time it's gonna go down, right? We should be following describes the numbers shaded on the 100 chart. 7's prime, 7's not prime. Now 3, 25. We have 5 and 5. Okay. What the fuck? Prime, composite. Fuck with the prime. No, not really. This is neither long. No, it's composite. What is the prime factorization of 73? I believe 73 is like 1. Elliot tried to shade only prime numbers on downward chart. 33 is not prime. Cool. Okay, I'm almost close.
What is the least common multiple of 36 and 12? So, and they say another way to say this is LCM in parentheses 36 and 12. And this is literally saying what's the least common multiple of 36 and 12? Well, this one might pop out at you because 36 itself is a multiple of 12. And 36 is also a multiple of 36. It's 1 times 36. So the smallest number that is both a multiple of 36 and 12, because 36 is a multiple of 12, is actually 36.
What?
There we go. Let's do a couple more of these. That one was too easy. What is the least common multiple of 18 and 12? And they just state this with a different notation. What's the least common multiple? Or the least common multiple of 18 and 12 is equal to question mark. So let's think about this a little bit. So there's a couple of ways you can think about. So let's just write down our numbers that we care about. We care about 18 and we care about 12. So there's two ways that we can approach this. One is the prime factorization approach. We can take the prime factorization of both of these numbers and then construct the smallest number whose prime factorization has all of the ingredients of both of these numbers, and that will be the least common multiple. So let's do that. 18 is 2 times 9, which is the same thing as 2 times 3 times 3. Or 18 is 2 times 9, 9 is 3 times 3. So we could write 18 is equal to 2 times 3 times 3. That's its prime factorization. 12 is 2 times 6. 6 is 2 times 3. So 12 is equal to 2 times 2 times 3. Now the least common multiple of 18 and 12, let me write this down. So the least common multiple of 18 and 12, 18 and 12 is going to have enough prime factors to cover both of these numbers and no more, because we want the least common multiple or the smallest common multiple. So let's think about it. Well, it needs to have at least 1, 2, a 3, and a 3 in order to be divisible by 18. So let's write that down. So we have to have a 2 times 3 times 3. This makes it divisible by 18. If you multiply this out, you actually get 18. And now let's look at the 12. So this part right over here, let me make it clear. This part right over here is the part that makes up 18, makes it divisible by 18. And then let's see, 12, we need 2 2's and a 3. Well, we already have 1 3, so our 3 is taken care of. We have 1 2, so this 2 is taken care of. But we don't have 2 2's, so we need another 2 here. So notice, now this number right over here has a 2 times 2 times 3 in it, or it has a 12 in it, and it has a 2 times 3 times 3, or an 18 in it. So this right over here is the least common multiple of 18 and 12. If we multiply it out, so 2 times 2 is 4, 4 times 3 is 12, 12 times 3 is equal to 36, and we are done. Now, the other way you could have done it is what I would say just the brute force method of just looking at the multiples of these numbers. You would say, well, let's see, the multiples of 18 are 18, 36, and I could keep going higher and higher, 54, and I could keep going. And the multiples of 12 are 12, 24, 36, and immediately I say, well, I don't have to go any further. I already found a multiple of both, and this is the smallest multiple of both. It is 36. You might say, hey, why would I ever do this one right over here as opposed to this one? A couple of reasons. This one, it's fun because you're actually decomposing the number and then building it back up. And also, this is a better way, especially if you're doing with really, really large and hairy numbers. Really, really, really large and hairy numbers where you keep trying to find all the multiples. You might have to go pretty far to actually figure out what their least common multiple is. Here, you'll be able to do it a little bit more systematically and you'll know what you're doing.
True, true.
we need to figure out the least common multiple of 30 and 25. So let's get our little scratch pad out here. And we care about 30 and we care about 25. And I'm going to do this using the prime factorization method, which I just like more. So 30, let's find the prime factorization of both of these numbers. So 30, it's divisible by 2. It's 2 times 15. 15 is 3 times 5. And now we've expressed 30 as the product of only prime numbers. 2 times 3 times 5. Now let's do the same thing for 25. 25 is, well, that's just 5 times 5. So let me write that down. 25 is equal to 5 times 5. Now to find the least common multiple, let me write this down. The least common multiple of 30, 30, and 25 is going to have a number whose prime factorization is a superset of both of these, or has all of these numbers in them as many times as we have in any one of these. So its least common multiple, well, it has to be divisible by 30, so it's going to need a 2 times a 3 times a 5. This is what makes it divisible by 30. But it needs to also be divisible by 25. And in order to be divisible by 25, you need to have 2 5s in your prime factorization. Right now, our prime factorization only has 1 5. So let's throw, so we have 1 5 right over here. We need another 5. So let's throw another 5 right over here. So now this thing clearly has a 25 in it. It's clearly divisible by 25. And this is the least common multiple. I could have had, if we just wanted a common multiple, we could have thrown more factors here, and it would have definitely been divisible by 30 or 25. But this has the bare minimum of prime factors necessary to be divisible by 30 and 25. If I got rid of any one of these, I wouldn't be divisible by both anymore. If I got rid of this 2, I wouldn't be divisible by 30 anymore. If I got rid of one of the 5s, I wouldn't be divisible by 25 anymore. So let's just multiply it out. This is essentially the prime factorization of our least common multiple. And this is equal to 2 times 3 is 6. 6 times 5 is 30. 30 times 5 is equal to 150. And of course, we can check our answer. 150, check it, and we got it right.
What is the least common multiple, abbreviated as LCM, of 15, 6, and 10? So the least common multiple is exactly what the word is saying. It's the least common multiple of these numbers. And I know that probably didn't help you much, but let's actually work through this problem. So to do that, let's just think about the different multiples of 15, 6, and 10, and then find the smallest multiple, the least multiple they have in common. So let's find the multiples of 15. So you have 1 times 15 is 15. 2 times 15 is 30. Then if you add 15 again, you get 45. You add 15 again, you get 60. You add 15 again, you get 75. You add 15 again, you get 90. You add 15 again, you get 105. And if still none of these are common multiples with these guys over here, then we might have to go further. But I'll stop there for now. So that's the multiples of 15 up through 105. Obviously, we can keep going from there. We can keep going from there. Now let's do the multiples of 6. Let's do the multiples of 6. 1 times 6 is 6. 2 times 6 is 12. 3 times 6 is 18. 4 times 6 is 24. 5 times 6 is 30. 6 times 6 is 36. 7 times 6 is 42. 8 times 6 is 48. 9 times 6 is 54. 10 times 6 is 60. 60 already looks interesting because it is a common multiple of both 15 and 60. Although we have 2 of them over here. We have a 30 and we have a 30. We have a 60 and a 60. So the smallest common multiple. So if we only cared about the least common multiple of 15 and 6, we would say it's 30. So let me write this down as a kind of intermediate. The LCM of 15 and 6. So the least common multiple, the smallest multiple that they have in common, we see over here. 15 times 2 is 30. And 6 times 5 is 30. So this is definitely a common multiple, and it's the smallest of all of their common multiples. 60 is also a common multiple, but it's a bigger one. This is the least common multiple. So this is 30. We haven't thought about the 10 yet. So let's bring the 10 in there. And I think you already see where this is going.
That
Let's do
number.
the multiples
3,
of 10.
30,
They're
30,
10, 20, 30, 40. Well, we already went far enough because we already got to 30. And 30 is a common multiple. 30 is a common multiple of 15 and 6. And it's the smallest common multiple of all of them. So it's actually the fact that the LCM of 15, 6, and 10 is equal to 30.
30.
Now, this is one way to find the least common multiple. Literally, just look at the multiples of each of the
Brute
number,
force.
and then see what the smallest multiple they have is in common. Another way to do that is to look at the prime factorization of each of these numbers. And the least common multiple is the number that has all of the elements of the prime factorizations of these and nothing else. So let me show you what I mean by that. So you could do it this way, or you could say 15 is the same thing as 3 times 5. And that's it. That's its prime factorization. 15 is 3 times 5. Both 3 and 5 are prime. We can say that 6 is the same thing as 2 times 3. That's it. That's its prime factorization. That both 2 and 3 are prime. And then we can say that 10 is the same thing as 2 times 5. That's it. Both 2 and 5 are prime, so we're done factoring it. And so the least common multiple of 15, 6, and 10 just needs to have all of these prime factors. And what I mean to be clear is in order to be divisible by 15, it has to have at least 1 and 1, 3, and 1, 5 in its prime factorization. So it has to have at least 1, 3, and at least 1, 5. By having a 3 times 5 in its prime factorization, that ensures that this number is divisible by 15. To be divisible by 6, it has to have at least 1, 2, and 1, 3. So it has to have at least 1, 2. And we already have a 3 over here, so that's all we want. We just need 1, 3. So 1, 2, and 1, 3, this 2 times 3, ensures that we are divisible by 6. And let me make it clear. This right here is the 15. And then to make sure that we're divisible by 10, we have to have at least 1, 2, and 1, 5. We have to have at least 1, 2, and 1, 5. These two over here make sure that we are divisible by 10. And so we have all of them. This 2 times 3 times 5 has all of the prime factors of either 10, 6, or 15. So it is the least common multiple. And so if you multiply this out, you will get 2 times 3 is 6. 6 times 5 is 30. So either way, hopefully both of these kind of resonate with you and you see why they make sense. This second way is a little bit better if you're trying to do it for kind of really complex numbers where you might have to be multiplying it for a long time. Well, either way, both of these are kind of valid ways of finding the least common multiple.
Kind of? I think it's really valid. I think I'm okay. I'm actually recording. Uh, 10 is 2 and 5, and 3 is just 3. So 2, 5, 10, 30 is gonna be 30. 12 is 2 already, so 2, 6. Let's see here. Right? Oh shit, it's gonna be 12. 4, 4, and then like. Wait, what? Let's do 8, 2, 4, and then 2 times 2. And for 10, we have like 2 times 5. So 8 times 5 is gonna be 40. Okay, it could be intuitively said. Look at it like that. Intuitively.
We're asked, what is the greatest common divisor of 20 and 40? And they just say, another way to say this is GCD, your greatest common divisor of 20 and 40, is equal to question mark. And greatest common divisor sounds like a very fancy term, but it's really just saying, what is the largest number that is divisible into both 20 and 40? Well, this seems like a pretty straightforward situation because 20 is actually divisible into 40. Or another way to say it is 40 can be divided by 20 without a remainder. So the largest number that is I guess you could say a factor of both 20 and 40 is actually 20. 20 is 20 times 1, and 40 is 20 times 2. So in this situation, we don't even have to break out our paper. We can just write 20. Let's do a couple more of these. So we're asked, what is the greatest common divisor of 10 and 7? So let's now break out our paper for this.
Wow.
So our greatest common divisor of 10 and 7. So
prime.
let me write that down. So we have 10. We want to think about what is our GCD of 10 and 7. And there's two ways that you can approach
5 and
this.
7.
One way, you can literally list all of the factors, not prime factors, just regular factors of each of these numbers and figure out which one is greater. So, or what is the largest factor of both. So for example, you could say, well, I got a 10, and 10 can be expressed as 2, or let me be careful, as 1 times 10, or 2 times 5. 1, 2, 5, and 10, these are all factors of 10. These are all, we could say, divisors of 10. And sometimes this is called greatest common factor. 7, what are all of its factors? Well, 7's prime. It only has two factors, 1 and itself. So what is the greatest common factor? Well, there's only one common factor here. 1. 1 is the only common factor. So the greatest common factor of 10 and 7, or the greatest common divisor, is going to be equal to 1. So let's write that down. 1. Let's do one more. What is the greatest common divisor of 21 and 30? And just another way of saying that. So 21 and 30 are the two numbers that we care about. So we want to figure out the greatest common divisor, and I could have written greatest common factor, of 21, and 30.
Why did I prime factor?
So once again, there's two ways of doing this. And so there's the way I did the last time where I literally list all of the factors. Let me do it that way really fast. So if I say 21, what are all the factors? Well, it's 1 and 21, 1 and 21, and 3 and 7. And I think I've got all of them. And 30, 30 can be written as 1 and 30, 2 and 15, and 3, actually I'm going to run out of them. Let me write it this way. So, space. 1 and 30, 2 and 15, 3 and 10, and 5 and 6. 5 and 6. So here are all of the factors of 30. And now, what are the common factors? Well, 1 is a common factor. 3 is also a common factor. But what is the greatest common factor, or the greatest common divisor? Well, it is going to be 3. So we could write 3 here. Now, I keep talking about another technique. Let me show you the other technique, and that involves the prime factorization. So if you say the prime factorization of 21, well, let's see, it's divisible by 3. It is 3 times 7.
3, 2, 5,
and the prime factorization of 30 is equal to, let's see, it's 3 times 10, and 10 is 2 times 5. So what are the most factors that we can take from both 21 and 30 to make the largest possible numbers? So when you look at the prime factorization, the only thing that's common right over here is a 3. And so we would say that the greatest common factor, or the greatest common divisor of 21 and 30 is 3. If you saw nothing in common right over here, then you would say the greatest common divisor is 1. Let me give you another interesting example just so that we can get a sense of things. So let's say that let's say these two numbers were not 21 and 30, but let's say we care about the greatest common divisor, not of 21, but let's say of 105 and 30. So if we did the prime factorization method, it might become a little clearer now. Actually figuring out, hey, what are all the factors of 105 might be a little bit of a pain. But if you do a prime factorization, you'd say, well, let's see, 105, it's divisible by 5, definitely. So it's 5 times 21, and 21 is 3 times 7. So the prime factorization of 105 is equal to, if I write them in increasing order, 3 times 5 times 7. The prime factorization of 30 we already figured out. Is 30 is equal to 2 times 3 times 5. So what's the most number of factors or prime factors that they have in common? Well, these two both have a 3. They both have a 3, and they both have a 5. So the greatest common factor or greatest common divisor is going to be a product of these two. In this situation, the GCD of 105 and 30 is 3 times 5 is equal to 15. So you could do it either way. You could just list out the traditional divisors or factors and figure out which of those is common and is the greatest. Or you can break it down into its core constituencies, its prime factors, and then figure out what is the largest set of common prime factors, and the product of those is going to be your greatest common factor. It's the largest number that is divisible into both numbers.
Oh, that makes sense.
Welcome to the greatest common divisor or greatest common factor video. So just to be clear, first of all, when someone asks you what's the greatest common divisor of 12 and 8, or they asked you what's the greatest common factor of 12 and 8, that's a C back there for common. I don't know why it came out like that. They're asking you the same thing. I mean, really, a divisor is just a number that can divide into something, and a factor, well, I think that's also a number that can divide into something. So a divisor and a factor are kind of the same thing. So with that out of the way, let's figure out what is the greatest common divisor or the greatest common factor of 12 and 8. Well, what we do is, it's pretty straightforward. First, we just figure out the factors of each of the numbers. So what's the 12 of 12? Or they asked you what's the greatest common factor of 12 and 8. That's a C back there for common. I don't know why it came out like that. They're asking you the same thing. I mean, really, that's a C back there. Divisor is just a number that can divide into something, and a factor, well, I think they're asking you the same thing. I mean, really, a divisor is just a number that can divide into something, and a factor, well, I think that's also a number that can divide into something. So a divisor and a factor are kind of the same thing. So with that out of the way, let's figure out what is the greatest common divisor or the greatest common factor of 12 and 8. Well, what we do is, it's pretty straightforward. First, we just figure out the factors of each of the numbers. So first, let's write all the factors out of the number 12. Well, 1 is a factor, 2 goes into 12, 3 goes into 12, 4 goes into 12, 5 does not go into 12, 6 goes into 12, because 2 times 6, and then 1 goes in, and then 12 goes into 12, of course. 1 times 12. So that's the factors of 12. Let's write the factors of 8. Well, 1 goes into 8. 2 goes into 8. 3 does not go into 8.
This is relaxing.
4 does go into 8. And then the last factor, pairing up with the 1, is 8. So now we've written all the factors of 12 and 8. So let's figure out what the common factors of 12 and 8 are. Well, they both have the common factor of 1. And that's really not so special. Pretty much every whole number or every integer has the common factor of 1. They both share the common factor 2. And they both share the common factor 4. So we're not just interested in finding a common factor. We're interested in finding the greatest common factor. So all the common factors are 1, 2, and 4. And what's the greatest of them? Well, that's pretty easy. It's 4. So the greatest common factor of 12 and 8 is 4. Let me write that down just for emphasis. Greatest common factor of 12 and 8 equals 4. And of course, we could have just as easily had said the greatest common divisor of 12 and 8 equals 4.
112?
Does take something funny. Greatest common divisor of 12 and 8 is 4. Let's do another problem. What is the greatest common divisor
let's try that.
of
I think it's going to be 5, but let's see.
And 20? Well, let's do it the same way. The factors of 25? Well, it's 1. 2 doesn't go into it. 3 doesn't go into it. 4 doesn't go into it. 5 does. It's actually 5 times 5. And then 25. It's interesting that this only has 3 factors. I'll leave you to think about why this number only has 3 factors and other numbers tend to have an even number of factors. And then now we do the factors of 20. The factors of 20 are 1, 2, 4, 5, 10, and 20. And if we just look at this by inspection, we see, well, they both share 1, but that's nothing special. But they both have the common factor of, you got it, 5. So the greatest common divisor or greatest common factor of 25 and 20, well, that equals 5. Let's do another problem. What is the greatest common factor of 5 and 12? Well, factors of 5, pretty easy. 1 and 5. And that's because it's a prime number. It has no factors other than 1 and itself. And then the factors of 12, 12 has a lot of factors. It's 1, 2, 3, 4, 6, and 12. So it really looks like the only common factor they share is 1. So that was, I guess, in some ways kind of disappointing. So the greatest common factor of 5 and 12 is 1. And I'll throw out some terminology here for you. When two numbers have a greatest common factor of only 1, they're called relatively prime. And that kind of makes sense because a prime number is something that only has 1 and itself as a factor, and two relatively prime numbers. A prime 1, some terminology here for you. When two numbers have a greatest common factor of only 1, they're called relatively prime. And that kind of makes sense because a prime number is something that only has 1 and itself as a factor, and two relatively prime numbers are numbers that only have 1 as their greatest common factor. Hope I didn't confuse you. Let's do another problem.
It's pretty sick.
Let's do the greatest common divisor of 6 and 12. I know 12 is coming up a lot. I'll try to be more creative when I think of my numbers. Well, the greatest common divisor of 6 and 12, what's the factors of 6 are 1, 2, 3, and 6. Factors of 12, 1, 2, 3, I almost should have these memorized by now. 3, 4, 6, and 12. Well, it turns out 1 is a common factor of both. 2 is also a common factor of both. 3 is a common factor of both. And 6 is a common factor of both. And of course, what's the greatest common factor? Well, it's 6. And that's interesting. So in this situation, the greatest common divisor, and I apologize that I keep switching between divisor and factor. The mathematics community should settle on one of the two. The greatest common divisor of 6 and 12 equals 6. So it actually equals one of the numbers. And that makes a lot of sense because 6 actually is divisible into 12. Well, that's it for now. Hopefully you're ready to do the greatest common divisor or factor problems. I think I might make another module in the near future that'll give you more example problems.
Cool. Word prop. Oh shit.
William and Luis are in different physics classes at Santa Rita. Luis's teacher always gives exams with 30 questions on them, while William's teacher gives more frequent exams with only 24 questions. Luis's teacher also assigns 3 projects per year. Even though the two classes have to take a different number of exams, their teachers have told them that both classes, let me underline, both classes will get the same total number of exam questions each year. What is the minimum number of exam questions William's or Luis's class can expect to get in a given year? So let's think about what's happening. So if we think about Luis's teacher who gives 30 questions per test. So after the first test, he would have done 30 questions. Then after, so this is 0 right over here. Then after the second test, he would have done 6.
Time's it. Oh shit, I think I need to take some medicine. Sorry. Be right back. So I kind of messed up. I was watching the video, and after watching the video, I did the G7 and LCM problems, but I noticed that my recording was actually paused. So now I'm actually already done with it. So what I'm gonna do is just, for the sake of showing
here, then
that I did it, even though it's right,
here,
practice says that it's complete and we already mastered it. I'm gonna rewatch the video.
here, then after the second test,
I left it at 51. Then after that, I'm gonna do the word problems again. Okay,
he would have
cool.
done 60. Then after the third test, he would have done 90. And after the fourth test, he would have done 120. And after the fifth test, if there is a fifth test, he would do, so this is if they have that many tests, he would get to 150 total questions. And we could keep going on and on looking at all the multiples of 30. So this is probably a hint of what we're thinking about. We're looking at multiples of the numbers. We want the minimum multiples or the least multiple. So that's with Luis. Well, what's going on with William? Well, William's teacher, after the first test, they're going to get to 24 questions.
So 120.
24. Then they're going to get to 48 after the second test. Then they're going to get to 72. 72 after the third test. Then they're going to get to 96. I'm just taking multiples of 24. They're going to get to 96 after the fourth test. And then after the fifth test, they're going to get to 120. And if there's a sixth test, then they would get to 144. They would get to 144. And we could keep going on and on and there. But let's see what they're asking us. What is the minimum number of exam questions Williams or Luis's class can expect to get in a year? Well, the minimum number is the point at which they've gotten the same number of exam questions despite the fact that the test had different number of items. And you see the point at which they have the same number is at 120. This happens at 120. They both can have exactly 120 questions, even though Luis's teacher is giving 30 at a time, and even though William's teacher is giving 24 at a time. And so the answer is 120. And notice, they had a different number of exams. Luis had 1, 2, 3, 4 exams, while William would have to have 1, 2, 3, 4, 5 exams. But that gets them both to 120 total questions. Now, thinking of it in terms of some of the math notation or the least common multiple notation we've seen before, this is really asking us, what is the least common multiple of 30 and 24, and that least common multiple is equal to 120. Now, there's other ways that you can find the least common multiple other than just looking at the multiples like this. You could look at it through prime factorization. 30 is 2 times 15, which is 3 times 5. So we could say that 30 is equal to 2 times 3 times 5. And 24, that's a different color than that blue. 24 is equal to 2 times 12. 12 is equal to 2 times 6. 6 is equal to 2 times 3. So 24 is equal to 2 times 2 times 2 times 3. So another way to come up with the least common multiple, if we didn't even do this exercise up here, says, look, the number has to be divisible by both 30 and 24. If it's going to be divisible by 30, it's going to have 2 times 3 times 5 in its prime factorization. That is essentially 30. So this makes it divisible by 30. And say, well, in order to be divisible by 24, it's going to need its prime factorization is going to need 3 2's and a 3. Well, we already have 1 3 and we already have 1 2, so we just need 2 more 2's. So 2 times 2. So this makes it, let me scroll up a little bit. This right over here makes it divisible by 24. And so this is essentially the prime factorization of the least common multiple of 30 and 24. You take any one of these numbers away, you are no longer going to be divisible by one of these two numbers. If you take a 2 away, you're not going to be divisible by 24 anymore. If you take a 2 or a 3 away, if you take a 3 or a 5 away, you're not going to be divisible by 30 anymore. And so if you were to multiply all these out, this is 2 times 2 times 2 is 8, times 3 is 24, times 5 is 120. Now let's do one more of these. Umama just bought one package of 21 binders. Let me write that number down, 21 binders. She also bought a package of 30 pencils. 30 pencils. She wants to use all of the binders and pencils to create identical sets of office supplies for her classmates. what is the greatest number of
3.
identical sets Umama can make using all of the supplies? So the fact that we're talking about greatest is clue that it's probably going to be dealing with greatest common divisors. And it's also dealing with dividing these things. We want to
7 for
divide these
binders
both
and
into
like
the
10 for
greatest number
pencils
of identical,
per
the
set.
greatest number of identical sets. So there's a couple of ways we could think about it. Let's think about what the greatest common divisor of both these numbers are. Or I could even say the greatest common factor. The greatest common divisor of 21, 21, and 30. So what's the largest number that divides into both of them? So we could go with the prime factor. We could list all of their normal factors and see what is the greatest common one. Or we could say, we could look at the prime factorization. So let's just do the prime factorization method. So 21 is the same thing as 3 times 7. These are both prime numbers. 30 is, let's see, it's 3. I'll check it right this way. It is 2 times 15. We already did it actually just now. And 15 is 3 times 5. So what's the largest number of prime numbers that are common to both factorizations? Well, you only have a 3 right over here. You don't have a 3 times anything else. So this is just going to be equal to 3. So this is essentially telling us, look, let's divide both of them we can divide both of these numbers into 3, and that will give us the largest number of identical sets. So just to be clear of what we're doing. So we've answered the question, it's 3, but just to visualize it for this question, let's actually draw 21 binders. So let's say the 21 binders. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, and then 30 pencils. So I'll just do those in green. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let me just copy and paste that. This is getting tedious. So copy and paste. So that's 20, and then paste. That is 30. Now, we figured out that 3 is the largest number that divides into both of these evenly. So I can divide both of these into groups of 3. So for the binders, I can do it into 3 groups of 7. And then for the pencils, I could do it into 3 groups of 10. So if there's 3 people that are coming into this classroom, I could give them each 7 binders and 10 pencils. But that's the greatest number of identical sets Umama can make. I would have 3 sets. Each set would have 7 binders and 10 pencils. And we're essentially just thinking about what's the number that we can divide both of these sets into evenly. The largest number that we can divide both of these sets into evenly.
Okay, cool. I'm gonna do the word problems again. Yeah, let's go. Oh, crap, 7 questions. I hate it. Destiny just received 2 separate gifts. My recording. Don't want to have the same problem. The first gift is a box of 18 chocolates, and the second gift is a pack of 12 cookies. Destiny wants to use all of doing identical snack packs for her cousins. It's gonna be 6. Carmen practices the trumpet every 11th day and the flute every 3rd day. Both in today. How many days until? Okay, 33 days. It's gonna be their like LCM. Sam and Carlos are bowling with plastic pins in Sam's living room. Remarkably, Sam knocks down 8 pins on every ball, and Carlos knocks down 9 pins on every ball. At the end of the day, Sam and Carlos have knocked down the same total number of pins. What is the least number of total pins that Sam and Carlos could have each knocked down? Oh, I guess it's like 72, right? What's the least number of total pins that Sam and Carlos could have each knocked down? Same total number of pins. Abe would like to plant the trees in rows with the same number of trees and are made of only one type of tree. What's the greatest number of trees Abe can have in each row? trees and rows that all have the same number of trees and are made up of only one type of tree. So 27 goes into 54 two times. So I think 27. For each row we have 1 pine tree and 2 oak trees. Miranda and Savannah are excited that the new store just opened in town. They go together the first day it opens. Each time Miranda goes to the store, she plans to spend $7, and each time Savannah goes to the store, she plans to spend $9. A few weeks from now, Miranda and Savannah are surprised that they have spent the exact same amount of money at the store. What is the least possible number of times that Miranda has been to the store? 9 times. 9 is prime and 7 is prime. And then if they're gonna match, then it's gonna be 9 times 7. So she's been in the store 9 times. Peter's Partizone sells cups in packages of 6 and plates in packages of 8. Shania is hosting a birthday party for her little sister and wants to have the same number of each item. So it's gonna be like their least common, right? So I guess 24, right? Because 6 is like 2 and 2. What the fuck am I saying? 2, 3, and 18 is like 3 2s. So their LCM would be this guy times 3. 8 times 3 is 24. Okay. No, not 24 plates. Because just 3 packages of plate. Because each package of plate contains 8. What's the least number of packages needed to buy? Then 3 packages of plate. There are 72 boys and 90 girls on the math team. For our next math competition, Mr. Johnson would like to arrange all of the students in equal rows. Only girls or only boys in each row. Wait, what? What is the greatest number of students that can be in each row? Whatever. Just looking for GCF. So 72 is 2 times 36. And 36 is 2 times 18, and 18 is 2 times 9, and it's 3 times 3. Right? And then we have 90, which is 2 times 45. 3 times 15, and then 3 times 5. So they have both 3's and a 2, but no 5. So how much is that? That's 18. 3, 9 times 2 is 18. What's the greatest number of students can be in each row? So there would be like 18 rows, but how much in each row? Holy shit, this is insane. Okay, this is kind of hard. What's the greatest number of students that can be in each row? Greatest number of students can be in each row. I can fit them into 18, but how many students in those 18? So I guess like I can divide 72 and 90 by 18, right? I think that's what's trying. Okay, so let's say 90 plus 72. It's gonna be 2 and 162. 160 divided by 18. So let's see. I think it's gonna be 9. 9, right? What's this? So 2, 7, 16. Okay. What's the greatest number of students that can be in each row? There would be 18 rows, and in each row there would be, oh crap, what is this? 9 students. What is this number? 90. Oh, 9 since I added them together. And 9 students for each row. I could be wrong. This could be 18 students in each row. I mean, their GCF is 18. So that's a number of rows. 9 students, right? Oh fuck, it should be 18? Are you kidding me? Are you kidding me? Oh my god. Oh shit, I overthink it. I hate it. Now it downgraded. Fuck. Ronald and Tim both did their laundry today. Ronald does laundry 6 days. I hate it. $54. 2, 3, 18. There are 32 forwards and guards in the Leo must include all players on team and once. Man, this is fucking me up. Leo must include all players on a team. 32 and 2, 16. And 2, 8, 2, 2, 2, 2. Okay. 2 times 2, 4 times 2, 8 times 2, 16. That's 4, then 2. Okay. And then we have 80 guards. It's gonna be 5 guards, I'm pretty sure. So 2, 40, and then 2, 20, 2, 10, 2, 5. All this one goes into it. We have 2, 4, 4. What's this? 4, 8, 16. Their GCF is 16. If Leo creates the greatest number of possible teams, how many guards will be in each team? So 16 times 5. So in each team, there are 16, right? Greatest number of possible teams. And then for each team, there would be like 5 guards and 2 forwards. Let's say 16 times 5 is 30. 8. Fuck, I made a mistake there. I hate it. What's the minimum number of games that Enzo could have played? Enzo wins 5 again. Let's vote Prime, so 11 games. Jasmine's completing art project. Okay, 44. This GCF, right? GCF, this GCF. 311. Then 2 and 22, and then 2 and 11. 11 same number. Yeah, there's mom's buying hot dogs and hot dog buns. Fuck, I did this already. The store does not sell parts. I'm pretty sure this 36. 56 seconds. I'm gonna fly. Same again. 5. This is insane. It's going to plant 63 tomatoes and okay. That's the GCF 63. What is this? 9 is divisible by 3. 81 is 9 times 9, so 3, 3, 3, 3, and This is 9, then y equal 3. How much trees is this? 21. Okay, so 21 is actually already a prime. No, it's not. It's actually 3 times 7. Okay, cool. It's prime. We have 9 rows. I'm gonna kill myself. Is incorrect. Okay. 13. 13 goes in 3 times. 24. 12. 3, 6, 72. How many pencils will be in each package? Yeah, it's 24. Because in each pack there will be 3 package and oh my gosh, correct. In each package there would be in 24 we have the 2 and 12 and then it's going 2 and 16 2 and 6 and then 2 3 and then 7 2 2 is like 2 times 36 and then 2 and 36 and 18 2 19 2 9 and 3 3. So if you have 3 here 1 3 and we have like 1 2 3 1 2 3. This is 2 times 2 times 2 8 and 24. Am I being hasty? How many pencils will be in each package? How many pencils? 72 pencils. 3 package, 24 pencils in each package. Are you shitting me? 18, 9, 3, 3. Then we have 24, 2, 12, 2, 6, and then 2, 3. 1. We all have that, right? 1, 2, 3. So their GCF is 24. 2 times 2, 4 times 2, 8 times 3 is 24. So if pencils will be in each package, 24 pen. Why is this correct? Why is this incorrect? So if we have, oh shit, I think it's because we have 24 packages. And then no, we don't have 3 packages. We actually have 24 packages, and in each package we have 3 pencils. Oh shit. Wow, I'm stupid. Wow, 42, 21. Wow, this is making me insane. Okay, I'm gonna take the unit test again. Am I supposed to take the quiz or the unit test? Take the unit test. Make the mastery again. Holy shit. Which of the following shows only multiples of 12? 1236. Is each prime number or composite? This is neither. This is prime. This is composite. I'm sure 4 one's prime. Okay, cool. Enter answers product. Like, what is prime factorization? 71. 71 is already prime. I believe. Could be wrong. Could be divisible by 3. If you have 27. Oh, that's more than that. No. Oh no, actually, let's try. Let's give it a try. 27 times 3. 1, 2, 6, 7. It's 81. Yeah, 7. Oh my god, this thing again. This is the thing that I lost earlier, where I overcomplicated things. And I'm pretty sure this question is pretty much wrong. Grab 45, 2, 15, 3, 5. Here, 2 and 36, and 2 and then 18, and then 2 and then 9, and then 3 and 3. You have 3, 3 there. It's 18. 3, 3, 2, 3, 2, 2. Let's do it again. Let's do it again. Yeah, I think this is the question that I kind of overthinking. 36, 12, yeah. And it's gonna do 18, 2, 9, 3, 3, 90, 2, 4, 5, 3, 15, then 3, 5. So 3, 3, 2, 18, cool. List all the factors of 48. Factors of 48. It's 1, 48, 2, and 24, I believe. It's divisible by 3. Yeah, it's 12. 8, 9, 11, 12. So it's gonna be 3. 316? I don't know. Yeah, it's 316. 18, 348. What before? Of course, it's 4 12s. 1, 2, 3, 4. 1, 2, 3, 4. This one. Right, there's no 3 here. It's definitely divisible by 3 though. It's divisible by 3. Let's see. 3, 11, 11, 9. 11 plus 7 is 18, plus 19 is 28. So no. It's 10. Let's see again. 3. 8 plus 7 is 15, so 18. Right? 18. 15, 18 plus 9 is 27. It's actually 27. So it's 9. Wow, it's divisible by 3, yes. But anyway, let's try again. Let's try again. I could be wrong. I could do it. I don't want to fuck up. So the first thing I did was 3 plus 8, that's 11. Plus 7, that's 18. Plus 9, That's 27. Yeah. This shows that 30 is a multiple of 10. 30 is a multiple of 10 because 30 is 3 times 10. Ronald and both did their laundry day. Ronald does every 6 day. 6, 2, 3, and 9, and 3, 3. So, for LCM, so that's 2, 3. So I'm going to multiply this by 2. We got 9 times 9. We have 18 days. 18 days. What's prime factorization of 10? Oh, wow. It's going to be 2 times 5. Okay, cool. We're back. Mastering this shit again. I hit I made a mistake here 3 times. Okay, so the next thing's just gonna cut into this part. Is gonna cut into me doing the quiz tree and then the unit test, and then the rest the notification checking and the scores checking. 3, 2, 1, go mad. Made a mistake. I paused the video. It wasn't recording earlier. Oh god, so bad. So I did all of this, and I don't know the last thing I shot in the video. Oh fuck, I made a mistake. So I guess I'm just gonna redo that in another time, just so I could add up total things. Start quiz. Shakira's baking cookies to put in packages for a fundraiser. Okay, I'm recording now. God, I hate it. I'm disappointed. Shakira's baking cookies to put in packages for a fundraiser. Shakira's made 86 chocolate chips cookies and 40 sugar cookies. Shakira wants to create an identical package of cookies to sell, and she must use all of the cookies. Greatest number of identical packages Shakira can make. Two packages. Cameron practices the trumpet every 11th day and the flute every 3rd day. Cameron practiced both on the flute today. How many days until Cameron practices? The same day. It's a third day. There are 32 forwards and 80 guards in Leo's basketball league. Leo must include all players on a team and wants each team to have the same number of forwards and the same number of guards. If Leo creates the greatest number of teams possible, how many guards will be on each team? Let's see. Wait, what? There are 32 forwards and 80 guards in Leo's. What does that even mean, forwards and guards? Okay, I get this one. I'm gonna find a GCF. Okay. 4, 8, 4, 8, 16. Is this correct? Is this 32? 2 times is 4, times 2, 8, times 2 is 16. Oh shit. Okay. Okay, cool. 5 twos. Now we have guard. 240, 220, 210, and 25. Okay, 1, 2, 3, 4. 1, 2, 3. I have 4, so it's gonna be 16. Yeah, I mean 16 times 5, I guess. Gonna be like 80, so 16. So they're like 16 for the number of groups, right? How many guards will be on each team? So how many guards? There are 80 guards. So 80 divided by 16. That should be like 5, right? 5 guards for each team. And then if this was forwards, then there would be like 2 only of them for each team. Lena is going to plant 63 tomato plants and 81 rhubarb plants. Lena would like to plant the plants in a row where each row has the same number of tomato plants and each row has the same number of rhubarb plants. What is the number of rows Lena can plant? Wait, 63 is already prime, isn't it? And 81 is 9 times 9, so 3 fours. And 27 times 3 is 81, right? 63 is not prime, is it? Sixty-three is 9 times 7, and that's gonna be 3 times 3. So we have 337, so we have 2 of them. Get 9 rows. Get 9 rows. Destiny just received 2 separate gifts from her great-great-grandmother. The first gift is a box of 18 chocolate candy bars, and the second gift is a pack of 12 cookies. Destiny wants to use all of the cookies and chocolate bars and cookies to make identical snack packs for her cousins. Okay, cool. It's pretty easy. Just 4, right? 4 snack packs. No, not really, not 4. It's let's see, 12, and then 2, 6, 2, 3, 18, 2, 9, and 3, 3. We have 3 and 3, 3 and 3, but no 3 more, no more 2. So that's gonna be 6. It's actual 6 pack. Crap, I made a mistake. I hit it. I didn't record earlier shit. All set for the unit test? Yeah, let's go. Where's the unit test? What is the prime factorization of 77? 77 is like 7 times 11. Oh, okay, 7 times 11 is already. It's divisible by 9. Okay, cool, let's see. 5 to 9 is 14. Plus 3 that's 17. Let's just do this in this way. 14, 17, 18, 19, 25, 27, yes. 27 is divisible by 9. Now let's count again because we don't want to fuck this shit up. So I have 5, 9, that's 14, 17, 18, 19, 25, 27. Which of the following 7 numbers shaded on this chart below? Um, Composite. They're all composite. Composite numbers. There's nothing prime. 30 is not prime. Yadir's mom is buying hot dogs and hot dog buns for the family barbecue. Hot dogs comes in packs of 12 and hot dog buns come in packs of 9. The store does not sell parts of a pack and Yadir's mom wants the same number of hot dogs as hot dog buns. What is the smallest total number of hot dogs that Yadir's mom can purchase? Well, depends on how much money she has. But Yadir's mom's buying hot dogs and hot dog buns. Comes in packs of 12. Am I supposed to find the LCM of this? 12 is going to be 2, 6, and then 2, 3, and then for 9. We have 3 times 3. So you have 3 times 3 times 2 times 2, or 3 squared times 2 squared. So we have 9 times 4, or 36. I'm gonna buy up to 36 hot dogs, Mom. But I'm not sure. What's the most number of hot dogs? It's actually the hot dogs. It is not the LCM. This should be the hot dogs only. What is the total number of hot dogs that Jadir's mom can purchase? Number of hot dogs. Oh, this is not in packs, so it's gonna be like hot dogs still. Total number of hot dogs Jadir's mom can purchase. Hot dog comes in packs of 12, so we got all this. This is saying hot dogs. If I just it's in pack of 12 times 36. Final number is multiple of 9. 18 is a multiple of 9. What's the following numbers? Which one is a factor of 78? Oh. Could be 6. It's divisible by 2, but in 3. 15, yeah. 6. Choose one answer. Divisible by 2. No. 5 is a factor of 45. It's going to be 45. 5 times 9 is 45. Sherman goes golfing every 6th day. And Brad goes golfing every 7th day. If Sherman and Brad went golfing today, how many days until they will go on the same day? It's gonna be 42 days. Okay, I guess I've mastered this section. Cool. Amazing. Okay, so let's see what's next. The next is reading and interpreting data. Wow, that sounds insane, but okay. Let's see how much we've improved. It's the old one, it shouldn't be 48 anymore. It turns 51. And in the world of math, it's gonna be 19. Yeah, 19. It's great, cool. Alright, see you guys on the next session, the next part. But I think this was part 13. And yeah, I'll do part 14 in a minute. Yeah, I'm gonna do it the same day. Bye.